A perfectly carved vertical hole hidden deep in the North Caucasus Mountains drops into the Earth like someone drilled straight toward the planet's core. Some people even compare the shaft to internal passages inside the Egyptian pyramids. Could there really be a connection between them? So the public learned about this mystery cave thanks to a local cave enthusiast who was hiking in the North Caucasus in 2011. The rugged slopes of the Khara-Hora mountain, with glacier-carved valleys and cliffs that have stood there against all sorts of weather for thousands of years, seem to be a perfect place if you want to hide something. And that's where Shemakov found something that looked like an entrance to an underground cave. He invited a team of cavers, and together they went down the shaft. At first, they were sure it was a geological formation, but the deeper they descended, the more it looked like something carefully built by humans. There were massive stone blocks that seemed fitted together so tightly that you couldn't push a knife blade between them. Some sources also say the shaft drops almost perfectly vertical, and its walls look polished, as if giant machinery smoothed them long before modern tools existed. But in reality, this smooth appearance results from natural geological fractures. What's really weird are openings resembling ventilation channels. These passages seem designed to move air through the structure. Natural caves rarely organize airflow this cleanly. That detail alone makes researchers argue whether someone designed and built all this intentionally. And if someone did build it on purpose, it would have to be one really advanced civilization. Some people said Shemakov described his discovery in every detail in his diary. But even if it really existed, it was lost. So we'll never know what was in it. In fact, we know so little about this man, and his discovery wasn't mentioned a lot on TV or elsewhere, that some people even questioned if he existed at all. Or maybe he saw something down there he shouldn't have seen. And there's no way to double-check, as he was hit by a car and passed away just 4 years after the discovery. This tragedy fueled even more rumors, speculation, and conspiracy theories. Geologists are trying to find a more logical explanation for this shaft, of course. The Caucasus Mountains are part of a massive chain called the Alpida Belt, which stretches all the way from southeastern Europe right into Asia. The Caucasus formed as a result of a tectonic plate collision. All these massive plates are still restless and constantly pushing against each other today. So the entire region gets hit with strong earthquakes on a regular basis. Plus, water, pressure, and chemical reactions can carve vertical shafts over millions of years. Underground rivers dissolve softer rock, and harder layers remain smooth, eventually forming deep chimneys. But erosion usually creates randomness, and Khara-Hora has symmetry, angles, and fitted stone features that resemble architecture more than accident. Now, getting inside the shaft is still extremely dangerous. You'd have to face sheer drops, unstable ledges, and oxygen levels that thin out deeper underground. Twisting tunnels make it super tricky to find your way, and locals warn that some of the first explorers who entered never returned. Luckily, modern teams can use ground-penetrating radar and remote sensors instead of human descent to study the shaft. With every new scan, researchers find more voids that are still unreachable. Meanwhile, Khara-Hora has interesting neighbors. For example, Verovkina Cave, currently the second deepest known cave on the planet. This monster drops nearly 1.5 miles straight down, deeper than 4 Empire State Buildings stacked end-to-end. Explorers descend through freezing waterfalls, razor-sharp rock corridors, and vertical pits that swallow light completely. Temperatures here hover just above freezing, and underground rivers roar through darkness nobody saw until recently. If you dare reach the bottom, prepare for a journey that will last weeks of staged camps, ropes stretching thousands of feet, and absolute trust in teammates. One mistake down there means you'll be gone for good. Verovkina constantly floods and reshapes itself year after year, so cavers have to deal with flood pulses all the time. Water cuts deeper into the limestone rock and expands chambers slowly but surely, and then, because of the volume, suddenly bursts through cave openings. But this doesn't stop scientists from going down there to measure oxygen, airflow, and mineral growth to understand how caves evolve over geologic time. And that's how explorers discover strange microbial life that somehow survives without sunlight and feeds on minerals instead of plants. These ecosystems resemble conditions scientists expect beneath icy moons like Europa or Enceladus. This means the cave could be a great training ground for future space exploration. But before we head to space, let's check out another super interesting cave system, this time in northern Spain. There's a chamber there which scientists call Pit of Bones. Explorers have to trek into a pitch-black underground maze to squeeze through a narrow shaft that suddenly drops straight down for 42 feet. At the bottom of that geological trap, you slide down a steep stone ramp into a cramped, muddy chamber that holds the largest and oldest collection of early human fossils ever discovered. It's a biological time capsule with the remains of at least 28 ancient humans, frozen long before modern history even began. Explorers also found over 6,500 fossil fragments mixed with the remains of at least 166 Ice Age cave bears, lions, wolves, and foxes that probably fell down the shaft by accident. But the human bones are a massive mystery because they seem to have ended up down there much earlier than the animals. Who these people actually were is still a huge debate. When researchers looked closer at their skulls and jaws, they noticed strong, super-early Neanderthal traits. Then things got even crazier when scientists miraculously extracted mitochondrial DNA from those ancient bones. It linked these individuals not only to early Neanderthals, but also to the Denisovans, a mysterious group of ancient humans found thousands of miles away in Siberia. It proves our ancestors were moving and mixing in ways far more complicated than anyone ever guessed. The drama doesn't stop at genetics, though. This dark cave might actually hold the world's first assassination mystery and its earliest funeral. Out of thousands of bones, archaeologists found absolutely no everyday tools or food waste, except for a single, carefully crafted quartzite hand axe they nicknamed Excalibur. Because of this, some researchers think the group intentionally lowered their deceased down the shaft with the axe as a ritual. It was probably a way to show compassion hundreds of thousands of years before we thought possible. At the same time, one of the skulls shows two identical lethal fractures that look exactly like intentional blows. To get the exact timeline for all this prehistoric drama, scientists use cutting-edge tech like electron spin resonance and uranium series dating, and finally locked down that is 430,000 years old. Now, let's jump across the world to another geological giant, Devil's Tower in Wyoming. The formation shoots nearly 900 feet above the surrounding land. Its surface has long vertical columns, and it looks like some careful hands carved them. But geologists explain the structure formed when molten rock pushed upwards underground and cooled slowly. As the rock cooled, it turned into hexagonal columns, similar to how drying mud splits into patterns, just scaled up to impossible size. Erosion later removed the softer surrounding rock and left the hardened core unprotected. Local tribes thought the tower was sacred and made up stories about giant bears clawing the stone during mythical hunts. Now, scientists agree on much of its volcanic origin, but debates continue about whether magma ever reached the surface or hardened entirely underground. Even after more than a century of study, Devil's Tower still has its mysteries. When you connect all these places, engineered shafts, endless caves, and underground ecosystem, one thing becomes clear. Earth hides entire worlds beneath our feet, and we've barely scratched the surface.
We all know about the Great Wall of China, but what about a massive Indian wall that was created from thorny shrubs and brushwood? This wall ran through the heart of India. It was smaller than the famous Chinese wall, but still extremely long and impressive. Why did we hear nothing about it, and why did it disappear? Let's figure it out. So, it all began in the 19th century. The British Empire decided to create a large barrier along a customs line right in the heart of India. This line stretched from the state of Punjab in the northwest to Madhya Pradesh. But what was the problem with this line? In India, salt was one of the most expensive products in the country, and the tax on it was very high. People didn't want to pay these taxes, so many smugglers transported salt from coastal areas to central regions. As a result, salt lost its value, and Britain incurred significant financial losses. That's why the idea of creating a living hedge to stop smuggling appeared. The point was not to waste time and effort building a stone wall, but instead to create a barrier made of trees, plants, and dense thorny shrubs. A barrier that could grow on its own. The idea of building a living hedge only seems simple. In reality, the builders faced enormous difficulties. At first, it was built mainly from dry branches that were brought in and piled into tall heaps, but such a wall quickly fell apart and the branches had to be replaced again and again. Then, a government official and botanist named Alan Octavian Hume was appointed Commissioner of Customs. He decided to use his knowledge of gardening and botany to strengthen the hedge. Which trees were better suited for dry soil and which for wetter areas? How could the most resilient species of shrubs be grown? How to destroy parasites and how to thicken the wall so that no one could pass through it. Alan Octavian Hume had to solve these and many other questions. That is why he is credited with the greatest contribution to the creation of this project. People used various Indian trees and shrubs, including dwarf plum trees and bamboo, as well as many local plants. They did not simply pile everything together, but focused on planting and cultivation. Eventually, the length of the hedge exceeded 1,100 miles, which is roughly the distance between New York and Miami. The average height of the barrier was about 8 feet, but in some places it reached 12 feet in height and 14 feet in width. It was guarded by around 12,000 British soldiers stationed along its entire length. The cost of maintaining the wall amounted to approximately $220,716 in today's currency. Of course, this didn't stop the smugglers. Caravans of camels loaded with salt broke through the hedge. Officers often clashed with locals. The wall was destroyed not only by people but also by natural disasters. In some areas, trees don't grow because of the hot, dry climate. In other places, the wall was washed away by floods. In some regions, the soil was simply not fertile enough. They planted again and again, dug trenches, brought ground from other areas, and worked tirelessly until they found the ideal solution for each climatic zone. To create just 1 mile of the wall, builders used about 250 tons of thorny brushwood and other organic material. Each year, people transported around 100,000 tons of plant matter to reinforce weak sections of the hedge. They used almost every type of local thorny shrub. In some areas where the soil was especially dry, the trees couldn't grow. Builders brought in tons of other soil, dug up the top layer, and replanted everything. In addition to this, people faced many problems that interfered with construction. For example, white ants attacked the hedge and destroyed large sections of the wall. Forest fires burned trees for many miles and deprived builders of construction material. Storms, hurricanes, and whirlwinds tore down parts of the wall. Builders had to construct large embankments to protect the wall from floods. One of the most unpleasant challenges was locust invasions. Just imagine millions of flying, buzzing insects swarming the wall and eating all the vegetation. Parasitic vines grew around the trees and simply destroyed them. In one area, rats appeared, and builders brought in a group of wild cats to fight the rodents. All the work to build the hedge took about 30 years. When the wall was completed, it was divided into about 100 sections, each guarded by patrol services. Of course, gaps still remained in the wall. Smugglers broke through it, throwing sacks of salt over the top or climbing the trees within the wall. Officers constantly clashed with them. After such massive and exhausting work, the wall was expected to last a very long time, but in 1879 it was no longer needed. The salt tax began to be collected directly at production sites, making smuggling pointless. Once the wall stopped being maintained, it began to deteriorate and overgrow. In some places, it was dismantled and used for firewood. In other areas, natural disasters finished it off. In modern times, it's almost impossible to find the remains of the hedge. Some sections of it were turned into roads. All the information we know about this fence is stored in the books and records of various researchers who communicated with local people or were directly involved in the process. Now, let's learn something about another much more famous wall located in China. This wall still remains the largest and most extensive structure ever built by humans. Its length is about 13,000 miles, roughly the distance from Alaska to South America. But it's not just a wall along a straight flat road. It goes up and down, twists and straightens across mountains and plateaus. It's no surprise that this massive construction was built over a span of 2,000 years. The Great Wall of China is divided into many sections and consists of towers, watch points, garrison stations, and barracks. All of this was built from bricks and cut stone blocks. To bind them together, builders used lime mortar. But not every part of the wall consists of structures with towers like the ones you see in photos and on the internet. In some areas, it's simply massive ridges of compacted ground. It's hard to imagine how titanic this labor was. All of these construction materials had to be transported into the mountains. People didn't just stack bricks on top of each other. They leveled the ground, reinforced the foundation, and built day after day, year after year, generation after generation. Today, many parts of the Great Wall of China are destroyed. Some elements were ruined by natural disasters, others by erosion, and many sections were destroyed by people. Some of the damage is connected to interesting legends. One of them tells the story of Lady Meng Jiang. Her husband was sent to build the Great Wall of China. For a long time, she received no news from him, so one day she decided to visit him and bring him winter clothes. When she arrived at the wall, she learned that her husband was no longer alive. Lady Meng Jiang wept bitterly in her grief. According to the legend, her sorrowful crying caused part of the wall to collapse. Millions of people built the wall over the course of 2,000 years. And this raises a question. Why? What was the point of all this construction? One of the main reasons was to protect the country from enemies. Essentially, the entire Great Wall of China is a long defensive line. The wall also helped unite and preserve the unity of fragmented states that eventually formed a single China. But what purpose does it serve today? It's a UNESCO World Heritage Site. It represents a symbol of culture, unity, and the history of the country. And from an economic point of view, it attracts millions of tourists from all over the world. Warning: if you're a devoted fan of ETs and accept every story about contact with them as fact, you might want to skip this video. What you're about to hear is the hard truth, and yes, it may be disappointing. On the other hand, if the idea of them makes you uneasy, this video might actually put you at ease. And if you don't believe in those little green cuties but constantly find yourself debating people who do, just show them this. First, you need to know that there's no solid evidence that intelligent extraterrestrial life exists. What does exist is strong evidence that all the so-called ET incidents you've heard about during your whole life actually have very reasonable explanations. One of the most famous examples is the Roswell incident. On July 8, 1947, a strange object crashed on a ranch in the state of New Mexico. It was described as a flying disc. First, a local newspaper reported the story. Then, the incident spread across the entire country. People claimed it was the crash of an ET spacecraft. Authorities said the object was a meteorological balloon. People didn't believe them. Rumors exploded. Many theories spread everywhere. Years later, after all the hype slowed down, the truth finally came out. The flying disc was part of a top-secret government project, a high-altitude balloon designed to detect signs of nuclear testing. But even after the truth was revealed, many people refused to accept it. The Roswell incident became a full-blown cultural phenomenon, especially among UFO enthusiasts. Yet, among the thousands of books, articles, and documentaries about Roswell, you won't find a single verified fact proving an ET spacecraft was ever involved there. That same year, another mysterious object was discovered and also caught public attention. No one knows exactly where it landed, but many people connect it to the Roswell incident. At first glance, this metallic fragment seemed extraordinary. Its internal structure looked unlike anything known at the time, which led some to believe it was part of an alien craft. Further analysis showed the object was made from an alloy of magnesium and zinc, with traces of bismuth, lead, and other elements. Of course, the presence of these elements alone doesn't prove the object was made on Earth, since these substances exist throughout the universe. Then, scientists examined the isotopic composition of magnesium and the rest of the materials, and they determined that the alloy was manufactured on Earth. Still, one thing about the sample raised eyebrows: bismuth. Some people speculated that aliens might use bismuth in some kind of propulsion or flight system. However, these ideas were purely speculative. The bismuth found in the samples contained impurities, which clearly showed it was produced using ordinary Earth-based manufacturing methods, not any unknown technology. But that technology would require a pure bismuth alloy. Unfortunately for UFO fans, the analysis showed that the bismuth in the sample contained lead impurities, which is clear evidence that no alien technology was involved. It was created on Earth by people. However, its manufacturing process was unusual because of the specific mix of elements. The object also had damage caused by impact and heat exposure. Most likely, it was a component of another top-secret surveillance balloon. Okay, how about another alien-like incident? This is the famous but though less well-known WOW signal. In 1977, a radio telescope in Ohio detected a strange signal from deep space. It lasted 72 seconds and stood out dramatically from the background cosmic noise. Astronomer Jerry Amon, who discovered it, was so shocked that he wrote "Wow" on the printout. The scientific community briefly suspected that this radio signal might be a message from alien technology, but it was never detected again. Later explanations suggested it may have been radio emissions from a neutron star, amplified by a cold hydrogen cloud. You can also find realistic explanations for other similar cases on the internet. However, Roswell and similar cases happened decades ago. But what about modern stories? You've probably seen videos recorded by pilots showing fast-moving, elusive objects in the sky. Scientists carefully analyzed these videos and found something interesting. The observed behavior contradicted the laws of physics. If an object moved that fast through air or water, friction should produce a visible heat trail or plasma glow. But nothing like that appears in the footage. Does that mean it's alien technology? Probably not. A much simpler explanation is that the cameras used weren't advanced enough to capture what was actually happening. We don't know the distance between the object and the camera. We don't know its real speed. It could be a visual artifact, a sensor glitch, or a lens distortion. If you still believe these recordings show real UFOs, ask yourself this: why, after all these years, do we still have no high-quality footage? Why is it always low resolution, blurry, and often black and white? Millions of unclear images mean nothing compared to a single clear, high-resolution video, and we don't have one. The probability that UFO sightings are optical illusions or sensor errors is far higher than the probability that they represent alien spacecraft. Many people simply want to believe in ETs, so they amplify hype about any news hinting at extraterrestrial technology. A perfect example is Oumuamua, the first known object to enter our solar system from interstellar space. Some people panicked, claiming it was an alien probe. In reality, it was almost certainly an interstellar asteroid-like object. Remember the more recent panic surrounding 3I Atlas? Online rumors claimed it was an artificial object that would approach Earth in November 2025 and change our lives forever. November has passed, the object is now moving farther away. No alien invasion happened. So does that mean the only way to find extraterrestrial life is to wait for random space rocks to pass by? Or hope someone records a UFO in 4K, or 1080 at least? Can we actually do something ourselves? Yes, we can search for technosignatures. Technosignatures are signs of technological activity that intelligent life could do. These are biosignatures like microbes or molecules that suggest simple life. But searching for biosignatures across space is incredibly difficult. Technosignatures are easier. They include radio signals, laser emissions, or atmospheric pollutants such as carbon dioxide or methane. Earth itself emits technosignatures detectable from afar, so why not look for the same on other planets? Where do we start? There are over 6,000 known exoplanets. Any alien technology would be based on the same physics and chemistry as ours, because the laws of physics are universal. Maybe massive solar panels on a distant planet produce excess heat we can detect. Or perhaps large-scale industry releases chemicals visible through powerful telescopes. There's a checklist of technosignatures scientists look for. When something matches the list, the real work begins. Researchers must confirm that the signal comes from technology, not a natural process in space. A few years ago, astronomers observed a Tabby's star, about 1,280 light-years away. Then, they noticed that it began to darken as some huge object blocked it. Its unusual dimming led to speculation about alien megastructures. They suggested it could be some giant alien ship that parked near the star. In reality, it was just space dust flying around. That's why every technosignature requires careful verification. However, so far, no confirmed technosignatures have been found. Space is vast. The planets are distant. Maybe we simply can't see each other yet. Even if there is intelligent life, our communication might be impossible with current technology for them and for us. One famous Italian-American physicist, Enrico Fermi, once summed this up with a simple question. Where is everybody? No. How is it possible that no one in the whole cosmos has contacted us yet? Perhaps the most uncomfortable answer is the simplest one. Maybe we really are alone. Of course, there's a possibility that the aliens just don't want to get in touch with us, or they're still developing their technologies for interstellar connection. But let's be realistic. Aliens don't exist. Probably. There's something absolutely massive and deeply unsettling hiding right next to Stonehenge. More than a dozen giant pits carved into the ground. They're all spaced with eerie precision and form a perfect circle, more than a mile wide. For years, nobody could explain them. They were too big to be animal traps, too organized to be natural sinkholes, and way too deliberate to be random. And the biggest question was, who had the power, knowledge, and reason to reshape the land on this scale 4,000 years ago? So these pits surround a place called Durrington Walls, a huge Neolithic settlement just a short walk from Stonehenge. Archaeologists now say humans dug them around 2500 BCE, during the late Neolithic period, when people supposedly lived simple farming lives without metal tools, written language, or modern math. Each pit stretches about 30 feet across and plunges roughly 15 feet down, and together they form an almost flawless ring. To prove the pits weren't natural, scientists went full detective mode. They drilled soil cores and tested the dirt itself, including microscopic traces of ancient DNA and something called luminescence dating, which tells you when the soil last saw sunlight. Every test pointed to the same answer. Humans made these pits on purpose. Here's where it gets wild. The pits weren't dug randomly as people moved along. They were laid out as a single unified project. That means Neolithic builders had to visualize a massive circle, measure distances across open land, and coordinate teams over a huge area without any GPS, drones, or even aerial maps. All they had were people, ropes, wooden tools, and shared knowledge. So why would they invest so much effort and do this? Archaeologists think the pits formed part of a ritual landscape, not a practical one. Durrington Walls already looks like a place where people gathered for ceremonies, feasts, and seasonal events. The pit circle may have marked a sacred boundary. It could have separated ordinary land from a spiritually charged space. Some researchers think the pits symbolized a border between the world of the living and the underworld. The scale of the structure is pretty impressive. It may be one of the largest prehistoric monuments ever built in Britain, even bigger than Stonehenge itself when you look at the total area. And unlike Stonehenge's towering rocks, This monument stayed invisible for thousands of years, quietly hiding under the grass. Generations walked over it without knowing they were standing inside a gigantic ancient design. For a long time, we underestimated ancient people. We imagined them reacting to nature instead of shaping it. But discoveries like this keep proving that wrong. The builders of Durrington Walls didn't just live in the landscape, but engineered it. They thought in terms of geometry, symbolism, and long-term meaning. And this isn't the only case. All over the world, thanks to new technology, scientists keep finding proof that ancient humans worked on massive scales with shocking precision. In the Amazon rainforest, researchers found traces of 2,500-year-old cities hiding beneath the jungle canopy. Scientists spent more than 20 years exploring the area on foot before technology finally cracked the case. The LiDAR technology, which is like X-ray vision that surveys a landscape using lasers to digitally peel away the jungle, scanned a massive area of over 100 square miles. It helped to spot more than 6,000 rectangular earthen platforms, which are likely used as homes or public buildings. They also found agricultural terraces, drainage systems, and carefully shaped farmland. This wasn't a random settlement. It was well planned. At least 15 distinct settlements appeared, all connected by wide, straight roads that cut cleanly through the landscape. These roads didn't follow rivers or slopes as you'd expect. They crossed each other at perfect right angles, forming a grid. The researchers believe people from the Quillamope and Upanu cultures lived there between about 500 BCE and 300 to 600 CE. They farmed corn and sweet potatoes, reshaped the land, and built a system that lasted for centuries. Discoveries like this prove something huge. Far more people lived in the Amazon than scientists ever thought. Tens of thousands, maybe even hundreds of thousands. And they didn't just survive there, they engineered the landscape. Just like at Durrington Walls, the real story hid in plain sight until technology caught up. Then there's Peru, with one of archaeology's biggest headaches, the Nazca lines. These gigantic designs of animals, plants, and geometric shapes stretch across the earth like an ancient message, so huge that only birds or satellites can see them properly. For decades, people have tried to figure out why the Nazca people made them, how they did it, and what those massive patterns mean. And until recently, the mystery stayed stubbornly unsolved. Walking the desert or flying over it, archaeologists would spot lines and figures and wonder if anything was missing. But the ones already known were just the tip of the iceberg. Traditional fieldwork, with people on the ground slowly mapping things out by hand, took forever. And even then, dozens of smaller designs were just too faint for the unassisted eye. So, instead of scanning the desert on foot, researchers taught artificial intelligence how to see patterns in aerial and drone imagery. They fed terabytes of pictures into trained models, and AI began flagging shapes, curves, and ancient outlines that had been hiding for centuries. In just about 6 months, it identified 303 previously unknown geoglyphs in the Nazca Desert. It almost doubled the number of figures we knew before and showed entire classes of designs. Some of these new shapes are tiny, just a few feet across, but they sit next to giant ones like the hummingbird or monkey. Thanks to all the new finds, scientists can finally start testing theories they had about the purpose of the lines. It looks like the lines weren't just decorations. Many may have been walkways or routes used for ceremonial movement. In case you're worried, AI isn't replacing archaeologists. They still check every promising lead on the ground and interpret everything the machines find. Back in Britain, the pit circle also connects to an even older structure, an early Neolithic site called Robin Hood's Ball. Because it stood so far from the famous stones, it felt like a side character. But it turns out Robin Hood's Ball is from around 3600 BCE, which makes it about 500 years older than Stonehenge itself. It's what archaeologists call a causewayed enclosure, which sounds fancy but really means a big circular earthwork made of ditches and banks. Instead of one clean trench, the ditches are broken into short segments with little gaps in between. And instead of keeping people out, it probably brought them together. Archaeologists think these enclosures worked as gathering places, spots for meetings, feasts, rituals, and social bonding among the first farming communities. Then came the twist no one expected. While preparing land at Lark Hill, a hillside northeast of Stonehenge, for new military housing, archaeologists found signs of another causewayed enclosure. This discovery flipped the map upside down. The landscape wasn't growing outward from Stonehenge, it was already alive long before the stones ever went up. As researchers dug deeper, they found hundreds of flint tools, beautifully made leaf-shaped arrowheads, chunks of human skull, and pieces of antler, likely used as digging tools. Then came the pottery. Different styles showed up in different places, some from the enclosure ditches, others from nearby pits. That matters because pottery styles often act like cultural fingerprints. The mix suggests something big. Different groups of people were visiting the same place and brought their own traditions, tools, and objects with them. All of this changes how we see Stonehenge. The stones didn't appear out of nowhere. They rose in a landscape already loaded with meaning, memory, and movement. Every new discovery like the ones near Stonehenge, in the Amazon jungle and Peru, forces archaeologists to rewrite textbooks and the whole world to rethink the idea of progress. It turns out that ancient people made up for the absence of steel and electricity with observation, creativity, and shared meaning. Earth isn't a perfect ball, we know that. But the real mystery is miles beneath our feet. Way down below the crust, the planet has been cooling down for billions of years, just not evenly. The Pacific side loses heat faster, while the African side slows that loss by trapping it longer. That difference is why Earth stays restless, with earthquakes tearing the ground apart and volcanic fire breaking through the surface. Think of Earth like a massive engine that's been shut off. The outside cools first, but deep inside, heat lingers. That internal heat is leftover energy from when the planet formed, and it's been slowly trying to escape ever since. For a long time, scientists assumed Earth lost heat evenly in all directions. Hot in the middle, slowly cooling everywhere else. But when a team at the University of Oslo ran simulations that rewound the planet 400 million years and tracked where the heat actually escaped, they saw something very different. The cooling wasn't symmetrical at all. One side of the planet is doing it faster than the other. The difference is striking. The Pacific Hemisphere, the side dominated by the world's largest and deepest ocean, has cooled by about 50 degrees Kelvin, which is roughly 90 degrees Fahrenheit difference, compared to the Africa-Eurasia side. The reason is basically insulation. Africa and Eurasia are on a layered ancient continental crust. The Pacific side is the opposite. It's mostly ocean, resting on a much thinner crust where warmth escapes easily. Plus, the cold seawater on top pulls that heat out non-stop. Because the Pacific side is cooling so fast, the rock deep underground is getting heavy and sinking back toward the core. It's like a giant slow-motion conveyor belt that drags the Earth's crust down with it. Heavy materials sink. As it sinks, it pulls on the edges of tectonic plates, creating stress, trenches, earthquakes, and chains of volcanoes. Most of Earth's earthquakes and volcanoes happen in a giant loop called the Ring of Fire. This is where the ocean floor gets cold, heavy, and sinks deep into the planet. All that sinking rock travels thousands of miles down until it slams into a massive continent-sized structure sitting right near Earth's core. Scientists call this a blob because the heavy ocean floor is constantly falling on top of it. The Pacific blob is squashed flat and pinned down, sitting heavy and locked in place. But the other half of the world is doing the exact opposite. Under Africa, there aren't many sinking plates to act as a weight. Without that pressure holding it down, the African blob is free to grow tall and light. It pushes upward, lifting the ground from below and reshaping the entire continent. In fact, that rising bubble is already starting to tear the surface apart. In East Africa, a massive crack known as the Great Rift Valley is slowly opening up as the ground is pushed from below. Eventually, the pressure will become so high that Africa will literally split in two, allowing a brand new ocean to rush into the gap. There's a cool theory that suggests these blobs might actually be the remains of an ancient planet named Theia. Some researchers believe that Theia crashed into Earth billions of years ago, and while part of it broke off to form the Moon, some heavy chunks might have sunk deep inside our planet. So, the reason our interior is so lopsided might be because we literally have pieces of a different world buried inside our own. But that's just a wild theory. Whatever their origin, the blobs matter because they help split the planet into two different behaviors. On the Pacific side, cold slabs keep sinking down and piling up. On the opposite side, heat builds up deep and pushes upward over time. One half is dominated by downward motion, the other by upward motion. And this imbalance doesn't stop at the mantle. It shows up at the very center of the planet because Earth's inner core is still growing. Liquid iron around it gradually turns solid and attaches to the core. This process doesn't progress at the same rate everywhere. One side of the inner core builds up faster than the other. This might sound like it should throw the planet off balance, but it doesn't. Earth's interior isn't rigid like a solid metal ball. Over time, stuff inside can gradually move around. Gravity pulls everything toward the center, helping everything get a bit smoother and keeping the core pretty round. But pretty round doesn't mean perfect. If you want a real example of how uneven Earth is on the inside, look at the Indian Ocean. Where there's more mass underground, gravity pulls a little harder. Where there's less mass, it pulls less. In the middle of the Indian Ocean, there's a huge anomaly called the Indian Ocean gravity hole. In that spot, Earth's pull is weaker than normal, so weak that it can't hold the ocean's surface up at the usual level. The water actually dips downward. You wouldn't notice it sailing through, but you'd technically be sitting about 300 feet lower than the rest of the world's oceans. It's an invisible valley in the sea caused entirely by missing mass deep inside the planet. However, Earth isn't the only world hiding a messy interior behind a smooth surface. Even the Moon is like this. Over billions of years, Earth's gravity slowed the Moon's rotation until it locked into place, keeping one face permanently pointed toward Earth. That's what we know as the near side and the far side. This mattered early in the Moon's history. The near side always faced Earth, while the far side always faced deep space. That long-term setup affected how heat was stored and released inside the Moon. When NASA mapped the Moon's gravity using two spacecraft called GRAIL, they measured something called the love number. It's a value that tells scientists how much a planet or moon flexes under gravity. The Moon's love number turned out higher than expected, which meant its interior was softer than it should be. When scientists looked closer at the gravity data, they found that most of this flexibility came from the side facing Earth. The Moon's near side is softer and warmer deep down, while the far side is cooler and more rigid. Measurements suggest the near side mantle is significantly hotter and more volcanic. That difference shows on the outside. Because the near side was so hot and soft, ancient lava could easily punch through the crust and flood the surface. That created those big dark patches we see at night. On the other hand, the far side stayed colder and stiffer, so the lava never flowed the same way. Back on Earth, the Pacific has another quirk worth mentioning. Our planet isn't just spinning in place. It orbits the Sun at over 66,000 miles per hour, and the entire solar system is moving through the galaxy like a car driving through a swarm of bugs. Over long periods of time, objects drifting in from deep space are more likely to hit the side of Earth that's moving forward. And because the Pacific Ocean covers such a huge stretch of that side of the planet, it naturally ends up catching more impacts than smaller oceans or continents. This creates a strange coincidence. The same hemisphere that is leaking the most heat from within is also the world's biggest graveyard for things arriving from the outside. Because it is so vast and lonely, space agencies even use its most remote coordinates as a spacecraft cemetery at a spot called Point Nemo. We deliberately aim satellites and massive space stations like Mir to crash right there. So the Pacific ends up taking the hits from two directions, by accident from the universe and on purpose from us. Earth is restless, continents drift, oceans open and close. In a few 100 million years, the map will look completely different. The Pacific is actually shrinking right now. Eventually, the Americas might crash into Asia, and a new ocean will have to take over the job of being the planet's main radiator and its front bumper. But for now, we should probably be thankful for that massive, chilly, unlucky ocean. Saudi Arabia is digging a pit about 1,300 feet wide for a project called the Cube. It's a giant box meant to hold a full indoor city, right in the middle of another city. It's designed to hold more people than some small towns and surround them with ever-changing digital worlds. What's hiding behind this futuristic design? Let's find out. Sure, a sci-fi Minecraft block in the middle of a historic city would definitely be a landmark, but for these architects, that is just a side quest. They actually want to create a full-scale metropolis inside a single structure. This cube, known as the Mukaab, will be the center of a brand new downtown district in Riyadh. The scale alone makes it one of the most ambitious construction projects on Earth. The plan calls for a perfect cube that stands over 1,300 feet tall and is just as wide. To put that in perspective, you could fit around 20 Empire State Buildings inside this thing. Everything here is stacked like layers in a massive high-rise, so instead of crossing streets, you'd ride high-speed elevators between levels. Inside that box, the plan is to build a colossal hall in the center. Concept art shows the roof as a massive curved screen that can project almost anything, a blue ocean above you or a sky from another planet. If it works, walking in won't feel like entering a normal building. It might feel like stepping into a different dimension. In the middle of that big space, there's a plan for a spiral tower. It's supposed to be even taller than the Eiffel Tower and have hotels, restaurants, and movie theaters inside. If you manage to book a room there, don't expect to see regular streets out your window. Instead, you'll get a view right into a massive hall, showing whatever cool digital scene is playing at that time. Surrounding this core, the rest of the cube is organized into layers that function like neighborhoods. It's a mix of homes, workplaces, and visitor areas with museums, indoor parks, and huge shopping districts. It's also supposed to have its own internal transit system to move you around, so you never have to step outside. In theory, this single building could house around 400,000 people at the same time. Saudi Arabia isn't spending this kind of money just to collect cool drone shots. The country wants less of its future tied to oil and more of it tied to visitors, tech companies, and big international events. New Murabba, the district around the cube, is supposed to turn Riyadh into a once-in-a-lifetime sightseeing destination. On paper, the cube works like a city-sized resort mashed together with a business district. If you live there, you sleep in the tower, work in the layers around it, and go out to parks, malls, and digital-themed worlds without ever stepping outside. For tourists, it's a giant, all-inclusive future city experience in a box. The timing is no accident. Riyadh is hosting the World Expo in 2030 and the World Cup in 2034. Millions of people will fly in with cameras in hand. If the cube is finished by then, it will instantly be on every influencer reel and every top 10 things you won't believe exist on Earth video. That's the kind of free marketing you can't buy later. This entire dream world comes with a price. The wider New Murabba project, with the cube as its centerpiece, carries an estimated cost of around $50 billion. That's the annual economy of a small country poured into one district. Early satellite images showed an empty patch of desert on the edge of the city. Later images from 2024 show a huge square crater exactly where the cube is supposed to stand. crews have already ripped out around 353 million cubic feet of earth, enough to fill thousands of Olympic pools. Zoom in and you'll see rows of excavators chewing through the ground like a metal army. That means we're way past the "is this fake" phase. Construction is already underway. The real question now is much tougher. Can you actually turn this thing into a working vertical city in one of the hottest capitals on the planet on time without creating the world's most expensive cautionary tale? First, there's the desert problem. Riyadh sits in the middle of a desert where temperatures can be extreme. In summer, afternoon temperatures can sometimes go past 113 degrees Fahrenheit and stay there. Now, a giant sealed box sounds like a perfect way to trap heat, which is great if you want to cook vegetables, but not so great if you want a comfortable city. The architects get it, so they designed the shape to help with temperature control. Instead of a flat box, the cube is wrapped in overlapping triangular panels based on traditional Najdi patterns. These triangles break up the harsh desert sun and add more shaded surface. They also leave small gaps where air can move through. The basic idea is simple: block some sunlight to keep the inside cooler. Even with that clever shell, cooling a place like this is still a huge job. You're basically trying to air condition a small city that someone stacked upright. Every single degree outside, every sandstorm, every long summer day pushes the system harder and sends the energy bill even higher. Then there's the fake sky problem. In the concept art, the center hall looks like something out of a sci-fi game. The ceiling and parts of the walls turn into one giant curved screen, so you don't just walk into a decorated lobby. You walk into an ocean scene, or a fantasy city, or a Mars landscape that surrounds you on all sides. That kind of trick already exists in a smaller form. The Sphere in Las Vegas, for example, covers its interior with huge LED screens and throws people into moving digital worlds. The Cube wants to push that even further. Its dome would need a display that's many times larger and can give high-end results without overheating. All of this has to fit inside a very unusual building. A normal skyscraper is just a tall tower, and engineers know how to handle that. The Cube is more like a giant hollow block with a big empty space in the middle and whole neighborhoods stacked around it. It still has to stand up and hold the outer walls, plus the central tower and dome, while the inside somehow doesn't turn into a cramped maze. Then there's the people problem. On a busy day, you've got crowds moving around. In an emergency, you'll need to get them out fast. That's hard enough in a normal mall, let alone in a stacked mini city. While the Cube looks like something from another planet, the main idea isn't. There are other examples of architects trying to squeeze everything they can into a single building. In Chengdu, China, the New Century Global Center already seems like a dream come true for introverts. It's huge enough to feel like a mini city under one roof. You can wake up in a hotel, stroll down indoor streets, and relax on a sandy beach under an artificial sun, all without seeing the real sky outside. Just outside Berlin, there's a huge old airship hangar that's now the Tropical Islands Resort. It's big enough to fit the Statue of Liberty standing up inside. While the countryside can be covered in snow, people inside are swimming in warm water, walking past palm trees, and hanging out under a fake summer sky. Saudi Arabia isn't new to giant futuristic projects. Neom, for example, includes plans for the Line, a straight, mirrored city stretching for miles across the desert, even after recent scalebacks. The same push is behind plans for huge stadiums and even a year-round ski resort in the mountains of the desert country. Which is not a bad thing, because even if these mega projects fall short, they push the limits of what cities can be. Thousands of years ago, people built pyramids that still confuse us. Today, technology finally lets us attempt something just as strange, only this time, it's a glowing cube in the desert. The Cube is an experiment in how far we can bend engineering and imagination at the same time. Whatever the outcome, it's guaranteed to give us some exciting photos. Deep beneath South Dakota inside the Sanford Underground Research Facility, workers are digging caverns nearly 4,800 feet below the surface. They drill, blast, and carve their way through solid rock. More than 800,000 tons of ground have been removed. They're not opening a mine, and they're definitely not looking for gold. They're digging for answers to some of the biggest questions humanity has ever asked. How does our world actually work at the deepest level? Why does matter exist at all? How are stars born, and how do black holes come into existence? The answers aren't hidden in some underground vault or buried treasure. Instead, these caverns are part of one of the most ambitious physics experiments ever attempted, the Deep Underground Neutrino Experiment, better known as DUNE. Down here, far below the noise of the surface world, scientists are installing enormous detectors designed to study some of the strangest and most elusive particles in existence, neutrinos. What are these particles? Why do we need to go nearly a mile underground to study them? And what could they possibly tell us about the universe and about us? Let's find out. By the end of this story, you'll feel a little more like a scientist. So why are neutrinos such a big deal? Because they're everywhere. They're among the most abundant particles in the entire universe. And yet, at the same time, they're almost completely invisible. These tiny subatomic particles pass through matter as if it barely exists. Right now, this very second, around 100 trillion neutrinos are passing straight through your body. But you don't feel a thing. Neutrinos are incredibly light. For a long time, scientists weren't even sure they had mass at all. That's why they're often called ghost particles. They're everywhere, constantly streaming through space, planets, and people, but almost never leaving a trace. Neutrinos are created whenever atomic nuclei collide or decay. They're born in nuclear reactions, radioactive processes, and energetic cosmic events. They even come from something as ordinary as a banana. Bananas contain potassium, which is slightly radioactive. That means every banana quietly produces neutrinos. Don't worry, the amount is completely harmless. You can eat bananas without fear. But the biggest neutrino factory anywhere near us is the Sun. Deep in its core, nuclear fusion is happening non-stop, and neutrinos pour out in staggering numbers. The Sun floods our solar system with them every second. And beyond the Sun, even more powerful sources exist. Exploding stars, supernovas, and possibly even black holes. Neutrinos may also be connected to one of the greatest mysteries in modern physics, the disappearance of antimatter. According to our best theories, the Big Bang should have created equal amounts of matter and antimatter. Antimatter is made of particles with opposite electric charge. When matter and antimatter meet, they annihilate, turning into pure energy. And yet, here we are, living in a universe made almost entirely of matter. The antimatter is gone. But why? Scientists don't know. One leading idea is that neutrinos played a role tipping the balance. Somehow, early in the universe's history, neutrinos and antineutrinos may have behaved slightly differently. That tiny imbalance could explain why matter survived and why galaxies, stars, planets, and people exist at all. So neutrinos might hold answers to how the universe works, how it began, and why it didn't erase itself. But there's a problem. To study neutrinos, you have to catch them. You have to observe their interactions, measure their properties, and see how they change. And that's incredibly difficult. That's why scientists are digging giant caverns in South Dakota. Why underground? Why not study neutrinos out in the open, in a field, on a mountain, or on a sunny beach? Because neutrino detectors need silence. Not silence from sound, but silence from radiation. Neutrino detectors are massive, extremely sensitive machines. They're built to notice incredibly rare events. But Earth is constantly bombarded by cosmic rays and background radiation. At the surface, those signals would completely overwhelm the data. Going deep underground solves that problem. Thick layers of rock act like a natural shield, blocking unwanted radiation and creating a quiet environment where neutrinos have a chance to reveal themselves. That's why DUNE's detectors sit underground. In total, DUNE will use 4 gigantic detectors, each about the size of a 7-story building. Together, they form a single experiment, but the heart of the project is actually far away, at Fermilab near Chicago, about 800 miles from these caverns. From here, a team of scientists will release neutrinos that will travel through the underground, and giant detectors will collect information about them and transmit the data. But how do they catch the information? The detectors will be filled with liquid argon. It's a cryogenic, colorless, odorless, and tasteless substance extracted from the air by liquefaction. Liquid argon creates an inert environment that greatly helps scientists in their experiments. Imagine that our world is a huge canvas with millions of drawings and colors. So liquid argon is such a white piece, a perfect place for studying tiny particles. When neutrinos collide with this liquid, they create other particles. Detectors read those particles and send the information to the lab. Then scientists from all over the world begin to carefully study these data. They hope to create a clearer picture of the universe, to understand why matter rather than antimatter dominates here. But what do we care about this information? Why is knowledge about matter important to us? Because we're part of this matter too. By manipulating particles, scientists will be able to find out what happens to neutrinos during the explosion of a star and the birth of a black hole. So, scientists collect invisible neutrino particles which are associated with the birth of the universe, star explosions, and black holes. They release them into a single beam and launch them through detectors. Everything seems clear, but where did they get the neutrino beam from? And how do they get them? It starts with hydrogen gas. Scientists take hydrogen atoms and strip away their electrons, leaving behind pure protons. These protons are then fed into a massive particle accelerator, where electric fields push them harder and harder, faster and faster, until they're moving at nearly the speed of light. Then they're smashed into a solid target made of graphite or beryllium. The impact is so hard that the atomic nucleus breaks into a spray of new unstable particles and explodes outward. Among those particles are pions. Pions are extremely short-lived. Almost instantly, they decay into other particles, neutrinos and antineutrinos. Powerful magnetic devices force the pions to fly in the same direction. Chaos becomes order. A wide spray of particles turns into a tight, focused beam. That beam then slams into thick blocks of aluminum, steel, and concrete. These blocks act like a filter. Muons and other leftover particles can't go through it, but neutrinos are different. They barely interact with matter at all and pass through the filter. What emerges on the other side is a clean beam of neutrinos. Right now, the caverns are complete. The first DUNE detector is expected to turn on before the end of 2028. Around 1,500 scientists from 36 countries are waiting for the experiment to begin. All of this might look familiar. Giant caverns, tiny particles. Scientists are chasing the deepest structure of reality. It sounds a lot like the Large Hadron Collider, but DUNE and the LHC have different goals. At the Large Hadron Collider, scientists accelerate particles, mostly protons, to near light speed and smash them together. The goal is to recreate conditions similar to those just after the Big Bang. The LHC has already confirmed the existence of the Higgs boson particles that help us to understand why some elementary particles have mass. The collider may also help uncover dark matter, an invisible form of matter that makes up about 27% of the universe. Stars, planets, galaxies, and everything we can see are about 5%. The rest is dark energy, a mysterious force expanding the universe. Dark matter, dark energy, invisible ingredients shaping reality itself. None of it is easy to understand, but experiments like DUNE and the LHC help us to make sense of it. We know more about space than we do about the ocean. We know more about the ocean than we do about the Earth's core. But how do we study something that lies more than 1,000 miles beneath our feet? Oddly enough, you need to fly into space. Thanks to satellites orbiting the planet, scientists have discovered something strange at the very heart of the planet. News about mysterious signals from space barely surprises anyone, but how about this? We detected strange signals coming from deep beneath our own home. Before we go into those signals, we need to understand why it's so important to study what's inside the planet. How does the core affect us? Our lives depend on it in several crucial ways. First, the core plays a fundamental role in gravity. We don't drift off into space because a massive spherical mass of molten metal locks us to the surface. Second, it powers Earth's magnetic field. Dangerous cosmic radiation and solar wind that could scorch everything are blocked thanks to the planet's magnetic field. And third, the inner processes of the Earth influence earthquakes and volcanic eruptions. Any disturbance inside the core and mantle can change life on the planet. And recently, scientists recorded something unusual coming from down there. At the beginning of this century, the United States and Germany launched a mission called GRACE, the Gravity Recovery and Climate Experiment. At first, this project used 2 satellites to track how water moved around the planet and how glaciers were melting. But the satellites could also measure Earth's gravitational field. If gravity was slightly stronger or weaker in some region, one of the satellites would be pulled toward that spot, and the other would measure the change in distance. In very simple terms, the heavier something is, the stronger its gravitational pull. In certain parts of the planet, gravity can be slightly higher because of large geological shifts, ocean currents, or melting ice. But between 2006 and 2008, the GRACE satellites detected a strange change in gravity along the coast of Africa. Melting ice, water movement, and other natural phenomena couldn't explain the anomaly. No one knew what it was at the time, but years later, scientists suggested that the nature of this signal was coming from the Earth's core. Researchers noticed that some minerals, like perovskite, can undergo a phase transition when exposed to enormous pressure and extreme heat. And there are many perovskites lying in the upper layers of the mantle. When the internal structure of this mineral reshapes, it becomes denser and shifts the surrounding rocks. Deep underground, this harder, solid part moves the softer molten rock. These movements reach the molten outer core and slightly deform it. This deformation inside the core alters the flow of molten iron, and this deep current of liquid metal directly affects Earth's magnetic field. That's why satellites recorded those fluctuations. So how does all of this affect us? We launch satellites, we use compasses, we rely on GPS. All of this works only because gravity and the magnetic field are stable, and both depend on the core. That's why it's so important to study the Earth's heart. And to do that, we don't need to dig thousands of miles. Movements on the surface can reveal what is happening inside. Studying vibrations in the crust, recording gravitational shifts, calculating, modeling, and forming hypotheses. It all sounds a little boring. Is there another way to figure out what's happening down there? We sent Voyagers into space, and some of them have already left the solar system. We descend into the depths of the Mariana Trench inside bathyskiffs. So what's the problem with drilling a shaft deep into the Earth's crust? Humanity actually has some experience with this. In the 1970s, Soviet geologists began drilling the Kola Super Deep borehole. It became and remains the deepest artificial borehole ever created. Its depth reaches 7.6 miles, deeper than the Mariana Trench and higher than Mount Everest. More than 50 years have passed, and humanity has not gone deeper than 7.6 miles. And do you know where the Earth's core begins? At about 1,800 miles down. That's almost 7 times farther than the distance to the International Space Station. To reach the core, we would need to drill a hole 230 times deeper than the Kola Super Deep. But that project was shut down in 1992, and the borehole was closed in 2005. What stopped us from digging deeper? First, the density of the rock. In the early stages, the drill easily cut through granite, but around 4.3 miles down, the rock became much harder. The drill broke several times. Workers had to change the drilling direction to pass through softer layers. Eventually, the borehole shape looked like a string of lights hanging on a Christmas tree. Another problem was heat. The deeper the engineers went, the hotter it became. Scientists expected that past a depth of 10,000 feet, the temperature would be around 212 degrees Fahrenheit. In reality, the harder they worked, the worse it got. Eventually, it reached 356 degrees Fahrenheit. The hottest place on Earth is the Sonoran Desert along the Mexican-US border. Temperatures there can reach 177 degrees Fahrenheit. That's twice as cool as inside that terrifying borehole. And the challenges did not stop there. At a depth of about 14,800 feet, the rock became porous. The extreme heat gave it a strange plasticity. Instead of solid stone, the drill had to cut through something more like hot, softened material that was almost impossible to drill. On top of that, the stability of the shaft became a danger. At such depths, the walls could collapse at any moment. To drill deeper, humanity would need completely new technology, a drill capable of working at 500 degrees Fahrenheit. That is the temperature scientists expect in the upper mantle, located just beneath the crust. And to reach it, we would need to drill 25 miles down, almost 3 times deeper than the Kola Super Deep. There are many rumors about what the engineers supposedly discovered in that hole. The most popular claim is that they heard the screams of thousands of people who were stuck in the fiery underworld. Other fake stories claim that the workers went insane after seeing something horrific at the bottom, and that's why the project was stopped. But if we ignore these myths, what did scientists actually find? They learned that the existing temperature model of Earth's interior was wrong. It was far hotter down there than expected. Geologists thought they would find the so-called Conrad discontinuity, a transition from granite to basalt. They found no such boundary. The real discovery was a liquid at incredible depths. Scientists found cracks filled with briny water. This changed our understanding of the crust. People used to believe it was completely solid, but now it appears full of fractures and channels through which water can move. Where did it come from? Geologists think the fluid was squeezed out of the rocks by enormous pressure, as water is wrung out of a sponge. But the most astonishing discovery was life. At about 4.5 miles down, engineers found ancient fossils of single-celled marine organisms. They were nearly 2 billion years old, and they had survived at such extreme heat and pressure. Let's imagine that one day we actually reach the mantle. What would that give us? What would we expect to see? We would finally understand how Earth formed billions of years ago, how the core, mantle, and crust developed, and how plate tectonics works. We'd know how the plates push and pull against each other. We'd gain a deeper understanding of earthquakes. Researchers also hope to find extremophiles. These are primitive organisms that can withstand extreme heat and pressure. If we discover life near the mantle or even within it, scientists will study it closely and try to understand how it manages to survive under such brutal conditions. If we learn what keeps life alive in the most hostile environment beneath our feet, we might learn how to protect life in other extreme places, from the depths of the ocean to distant planets. Studying the heart of our planet could reveal technologies we can barely imagine today. Our future might depend on the mysteries hidden beneath our own world. When people think of disasters, they imagine something loud. Unexpected earthquakes that snap roads in seconds, gas explosions that bring down buildings, volcanic eruptions that cover entire cities in ash. But sometimes, the real danger is creeping in without a sound. Parts of Arizona are sinking, slowly losing elevation year after year. Why is this happening? And just how much damage can something like this actually cause? Arizona isn't sitting on solid rock. It's sitting on a geological layer cake of sand, clay, and gravel. Think of the ground beneath your feet like a giant wet kitchen sponge. When a sponge is full of water, it's fluffy and holds its shape. That water isn't just in the dirt, it's what's holding everything up. Here's where things go wrong. People pump out that water to use it, but if they take it out faster than nature can put it back in, the gaps start to close. The grains get squished together by the weight of everything above, and when that happens, the ground starts losing the fight. Without the water to hold them apart, the dirt layers collapse under the weight of the world, almost literally. But once that happens, it's not like a sponge anymore. It's like a crushed soda can. You can't just blow air into a flat soda can and fix it. The structure is ruined. Once those underground layers are crushed, they stay crushed forever. Even if it rains for 40 days and 40 nights, the ground can't hold the water anymore. This is called land subsidence. It doesn't matter if water is pumped out or if rainwater rushes away too fast. If underwater pressure drops for long enough, the land starts to sink. And it's not just a one-time thing. Every year that more water is pumped out, the land sinks a little more. Over time, these changes can reshape entire towns and regions. So how do scientists notice something this subtle? From the ground, subsidence is hard to spot. The surface doesn't suddenly drop in one obvious place. Buildings don't suddenly tip over. You won't wake up one day to see your neighbor's house being a few inches lower than yours. Most of the time, everything looks normal. So to really see what's happening, scientists have to look from above, way up from space. Scientists use INSAR satellites, super precise scanners in orbit that can spot ground changes thinner than a US nickel from hundreds of miles away. Using this method, scientists tracked parts of Arizona over several years. What they found was alarming. Large areas weren't just sinking a little. Some places were dropping by inches every year. In certain regions, the total drop added up to several feet in just a short span of time. And this wasn't limited to one small spot. Entire basins were moving downward together, like a slow-motion elevator heading down. What made this even more concerning is that the sinking didn't stop during the wetter years. Even when rainfall increased and water levels rose a bit, the land kept sinking. In some places, this process actually sped up. That told scientists something important. The ground wasn't just reacting to short-term weather, it was responding to years of pressure building underground. Even from space, the pattern was impossible to miss. Wide regions glowing on satellite maps, showing steady downward motion year after year. What looked stable from the street turned out to be quietly shifting across miles of land. And once scientists could see it clearly, a bigger question emerged. What now? The surface can only take so much before it snaps. The land doesn't sink evenly. One spot drops fast, another barely moves. That pulls the surface in opposite directions. The surface tries to stretch, but eventually it snaps. And we aren't talking about sidewalk cracks. The earth literally rips open, creating jagged wounds called fissures, wide enough to split roads apart and damage paved highways. Infrastructure absolutely hates this. Roads bend, twist, and buckle. Pipes and cables buried underground are yanked out of alignment or torn apart. Canals that depend on a gentle, steady slope suddenly stop flowing the way they're supposed to. Even buildings that look fine at first start to give themselves away. Floors can tilt, doors might refuse to close, and long fractures can appear across walls. Wells are affected too. As the ground compacts, it crushes the underground rock layers like a vise. This closes off the flow, turning a working well into a dry hole. Basically, by pumping too much, we're breaking the pump. But it might get worse. These problems spread across entire basins, meaning damage can show up far from where the sinking first began. By the time surface damage becomes obvious, the underground changes that caused it may already be locked in, which means the real challenge isn't fixing the cracks you can see. It's dealing with the ground that's still slowly changing beneath them. So, can this be stopped? Or maybe reversed? Here's the harsh reality. There is no undo button for this. Once that underground rock is crushed, it stays crushed. The best we can do is step on the brakes and stop it from getting worse. One approach is artificial recharge. Arizona has built massive systems to move water across the state. One of the biggest is the Central Arizona Project, a canal that stretches more than 330 miles, carrying water from the Colorado River deep into the desert. They dump massive amounts of water into giant empty fields called recharge basins, letting it seep back underground to repressurize the earth. It's not fixing the crushed sponge. That damage is done. It's more like loosening your grip so you don't crush it even more. You don't get the space back, but you can keep things from getting worse. The other approach is tougher. Arizona drew some hard lines on the map. They're called active management areas, and inside them, groundwater use is tightly limited. You can't just drill a well anywhere and pump non-stop anymore. The goal is to stop one area from sinking so fast that it pulls everything around it down too. In places like Phoenix and Tucson, where these rules kicked in early, the sinking actually slowed down. In other parts of the state where pumping stayed heavy and rules were looser, the ground kept dropping. Not because the idea doesn't work, but because slowing subsidence only works if pressure is eased early. Arizona is just the latest member of the Sinking Cities Club. In fact, there are far worse cases around the planet. Look at California. The Central Valley there is basically the world champion of deflation. Farmers have been pumping water out of the ground so aggressively for so long that in some spots, the land has dropped by 30 feet. It's gotten so bad that gravity-fed canals are confused because water doesn't like flowing uphill. Then you have Mexico City. The problem there goes back hundreds of years. The city was built right on top of an ancient drained lake bed. As water was pumped out to support a growing population, the ground began to sink. In some neighborhoods, buildings now sit many feet lower than they did a century ago. Streets have been repaved again and again, not because they wore out, but because the city itself kept dropping. It's happening all over the map. From coastal towns to big farming hubs, the ground is getting tired of holding us up. Arizona is just proving how sneaky this can be. It quietly reshapes the world while we're busy looking at our phones, which makes you wonder. If huge chunks of the planet can sink this quietly, how many places are changing right now without anyone noticing? It really makes you rethink the phrase solid ground. Maybe the ground floor will become a basement in 30 years. Or maybe it's just Earth sending us a bill for all the water we carelessly throw away. Okay, just like Arizona, those jokes are a bit dry, so I'll stop now before I sink any lower. Thanks for watching, and try not to let the situation get you down. Deep under the ground, beneath the forests, the rivers, and the cities of Brazil, scientists have found a treasure. Not chests full of gold coins and jewels. This treasure isn't oil either. In fact, 100 years ago, almost nobody cared about this material at all. But today, this treasure has the power to turn any country into a superpower. So what is it? Ready? Brazil has discovered enormous deposits of REE, rare earth elements. If you want a shorter name, just call them the new gold. Rare earth elements are a group of 17 elements from the periodic table. Chemists divide them into two groups, light rare earths from lanthanum or europium, and heavy rare earths from gadolinium to lutetium. For most people, these names sound like magic spells from the world of Harry Potter. Avada Sumarium, Expecto Gadolinium. You may never have heard of these names before, but they're hiding everywhere around us. Our modern world would collapse without them. We call them rare because they don't usually gather in one place. They're spread out through large areas of rock and soil, so it takes a lot of work to collect them. They're hiding from us, and we have to dig and separate and process huge amounts of ground before we get a small amount of these elements. But what do we get in return? We get technology. We get clean air, better energy efficiency, lighter parts for machines, brighter screens, and stronger magnets. Rare earth elements are like secret ingredients. On their own, they don't look impressive. But when you combine them with other materials, they produce powerful reactions. They make glass for lenses, engines, phones, headphones, MRI machines, solar panels, and many other things. Without them, airplanes would be heavier, rockets would be slower, screens would be darker, and many products simply wouldn't exist. One example is neodymium, which is used to make magnets. Not those that you put on your fridge after travel. A wind turbine needs a magnet made from neodymium. That turbine produces electricity. The electricity charges your laptop. Your laptop lets you watch videos and play games. It's just a magnet, but it directly affects your life. But this magnet can't exist without neodymium. A tiny element in the ground becomes a tiny part inside a giant production that keeps our modern world running. And this is far from the only use of neodymium. And here is why Brazil matters. This country has a chance to become the second largest supplier of rare earth elements in the world and the #1 outside of Asia. Mining these elements creates jobs for thousands of people. Processing and selling these metals is a huge boost for the economy. But talking about economic indicators is boring, so let's play a game instead. You'll hear the name of a rare element like a spell from a magic book and try to guess what it's used for. Yeah, once the game is over, you won't magically turn into a REE expert, but you'll surely get to know the subject matter. Maybe you'll even want to work in this field someday. Ready? The first element is scandium. What is it used for? Making books, baseball bats, or chainsaws? The answer is bats. People use scandium to make super strong metal alloys and ultra-light components. Where else can we see it? In bicycle frames, aerospace parts, rocket components, stadium lights, and even X-ray machines. Scandium helps send spacecraft into the sky and produce semiconductors. You've heard that word many times, but many people don't know what it means. A semiconductor is something that can let electricity through and also block it. It's like a tap. Water can flow or it can stop. Semiconductors do the same thing with electric current inside microchips. They're essential for every piece of modern electronics. Next, yttrium. Where can you find it? TVs, ceramics, or batteries? It was a tricky one, so the answer is everywhere. Plus, this element is essential for superconductors. A superconductor is a material that can carry electric current with zero electrical resistance, meaning no energy is lost as heat. In ordinary materials, electricity always produces heat because of resistance. But when superconducting materials are cooled to very low temperatures, resistance disappears and current flows perfectly and safely. Yttrium-based components are crucial components of certain high-temperature superconductors, helping make them practical and usable in real-world applications. So this is also a crucial element for scientists who love to conduct experiments with extremely low temperatures. Yttrium is also added to metals to make them stronger, more heat-resistant, and even more resistant to radiation. In other words, this element is a magic boost for metals. Here comes lanthanum. It sounds like a mighty wizard from a fantasy world who uses spells of illusions or mind control. But what is it for in the real world? Lenses from video cameras? A pencil lead? Air conditioners? Lanthanum is used to make optical glass in camera lenses. When you watch a beautiful scene in a movie or take a photo with your phone, you can quietly thank lanthanum and the people who mined it from the ground. It's also used in oil refining, helping us get fuel and energy that our machines need. Cerium is yet another unsung hero. What does it do? Does it help purify the air, boil water in a kettle, or ensure the operation of vacuum cleaners? It helps the environment. Cerium is used in catalytic converters. These devices clean toxic gases from car exhaust. Without cerium, the air in big cities would be much dirtier. Cerium is also used to clean water and to produce glass that protects from radiation. In a way, this rare element is our shield against poison, pollution, and radioactive danger. Now meet praseodymium. I've got a hint here. It's used in extreme conditions. Which ones? Cold, heat, or vacuum? Praseodymium helps to carry out work in extremely low temperatures, far below the coldest point in Antarctica. It's also used in lasers, magnets, and even for making yellow-green pigments in glass and ceramics. So next time you see a cup colored that way, you can nod wisely and say, "Ah yes, I see a praseodymium." The next element is essential for anyone who loves music. Meet neodymium. What do you think? Are these headphones, microphones, or synthesizers that work thanks to it? This element is used to make magnets that are necessary for speakers, headphones, and hard drive production. It also helps to create high-strength permanent magnets, which are crucial for electric car engines, wind turbines, and many other things. But for most people, the magic of neodymium is simple. It gives us music in our headphones while we ride the bus, walk in the park, or relax at home. REE are everywhere. Even if some objects doesn't contain them inside it, rare earths are probably used to make the machines that produced this object. But that is not all. Brazil also has huge deposits of graphite. Graphite is not a rare earth element, but it's still extremely important. When people hear the word graphite, they think of pencil tips, but that is only a tiny part of its story. Graphite is used to make fire-resistant laboratory containers, lubricants for machines, heat insulation for buildings, anti-corrosion coatings, chemical reagents, and even parts of nuclear reactors. Another treasure that Brazil has is lithium. It's not REE, but our modern world depends on it very much. Today, most modern batteries can't work without lithium. Your phone, your laptop, your electric car, iPad, and camera. All of these devices run on these batteries. Most of the world's lithium comes from Australia. Argentina and Chile produce large amounts too, but Brazil is rising fast. In 2023, this country became the 5th largest producer of lithium. Soon, it may reach 3rd place. Brazil is also a global supplier of nickel, which has its own long list of applications. But we'll stop before your brain melts from too much information. Now you've heard about rare earth elements and the surprising role they play in our lives. They're invisible to us, but they power our world. They help us travel, communicate, create, and dream. That's why this treasure under the soil of Brazil is so valuable. It's not just elements, it's the future. Game over! Congratulations, you've just completed REE 101. Here's your certificate. See you next time! Turkey is quietly tearing itself open, and no one noticed for decades. Scientists didn't just get a detail wrong, they misunderstood the entire motion of a massive chunk of Earth's crust. What they thought was sliding sideways is actually stretching apart, inch by inch, like the planet is slowly pulled in two. And once you see that rupture, you start noticing them everywhere. To understand why this shocked geologists so badly, picture Earth's crust like a cracked shell floating on something hot and squishy underneath. Those cracked pieces are tectonic plates. They move a few inches per year, which sounds tiny, but over millions of years, it reshapes continents. Turkey sits in one of the most uncomfortable places on Earth, squeezed between 3 huge plates: Eurasia to the north, Africa to the south, and Arabia pushing in from the southeast like an elbow in a crowded bus. For decades, scientists believe Turkey survived this squeeze by sliding sideways. This type of movement is called a strike-slip fault, which basically means 2 chunks of land grind past each other like hands rubbing together. Turkey has famous ones, like the North Anatolian Fault, which produces horrible earthquakes. That model felt neat and logical. Pressure comes in, land escapes sideways. Problem solved. Or so everyone thought. But geology doesn't always follow neat models made up by humans. There is a long fracture running beneath salt flats and farmland under central Turkey. It never behaved like the dangerous sideways faults, so it got less attention. Then researchers from Curtin University decided to look closer. And instead of watching earthquakes, they watched lava. Ancient lava. Lava that flowed across the fault thousands of years ago, cooled into solid rock, and later ruptured apart. There are tiny crystals called zircons inside that lava. They're basically nature's stopwatches. Zircons trap radioactive elements that decay in a predictable rate, so scientists can tell exactly when the lava cooled. When they matched lava chunks on opposite sides of the fault and measured how far they drifted apart, the team managed to reconstruct how the fault was moving over thousands of years. It turned out that the fault wasn't sliding sideways at all. It was slowly and steadily pulling apart, just a fraction of an inch per year. That's thinner than a grain of rice, but over geological time, it's massive. This type of fault is called an extensional fault, which means the crust stretches until it thins and breaks. In simple terms, Turkey isn't just being squeezed, it's being torn open. And as if that wasn't dramatic enough, the story gets worse. Other studies show that parts of Turkey's crust aren't just stretching, they're dripping downward into the mantle. When dense chunks of crust get heavy enough, they peel off and sink like blobs of wax in a lava lamp. Scientists call it lithospheric dripping, and this process is basically Earth quietly losing pieces of itself. When that happens, the surface above weakens. The land rises, sinks, fractures, and rearranges. Earthquakes don't always need plates to slam together. Sometimes the ground fails because its support system melts away from below. That's why Turkey's geology now looks less like a solid slab and more like stretched taffy over a fire. Turkey isn't alone with the tectonic drama. Africa is unzipping itself so slowly that no human will ever wake up to a brand new ocean outside their window, yet fast enough that scientists can measure it happening right now. Deep beneath East Africa, the ground stretches and thins. Over millions of years, that constant stretch doesn't just rupture rocks, it rewrites geography. And it can literally create an ocean where solid land once stood. All of this focuses on something called the East African Rift System. This rift runs thousands of miles across places like Ethiopia, Kenya, Tanzania, and Mozambique, and it ranks among the largest rift zones on Earth. A rift zone is where the planet's crust is being pulled apart instead of being squished together. Africa doesn't just have a rift zone, but one of the most extreme versions anywhere, and it's been stretching for tens of millions of years, like a slow-motion disaster movie. And the continent isn't one solid piece anymore. It's splitting into two massive tectonic plates. The Nubian plate sits to the west, the Somalian plate to the east, and they're drifting apart at less than an inch per year, which sounds like a joke until you realize your fingernails grow at about the same speed. But just like in Turkey, this tiny movement adds up over millions of years. Back in 2018, photos of a massive rupture in Kenya caused chaos over the internet, and headlines panicked everyone with the news that Africa was splitting in half. The image looked intense, but it didn't mean the continent snapped overnight like a broken cookie. A much deeper process has been going on for about 25 million years already. And if we could jump another 5 or 10 million years into the future, we'd probably watch the crust stretch so thin that seawater finally rushes in and fills the gap. While Africa is tearing apart vertically, like a slow zipper, India could be splitting in a totally different way, horizontally into two giant layers, each about 60 miles thick, right as it crashes into Eurasia. And this collision is what gave us the Himalayas and the massive Tibetan plateau sitting behind them like a high-altitude backstage area. Everyone agrees on the basics. India has been creeping north for over 60 million years at about the speed your hair grows, slamming into Eurasia and forcing rock upward until it turned into the tallest mountains on Earth. What no one fully agreed on was how Tibet got so insanely high. Some scientists thought India was too buoyant to sink and just slid underneath Eurasia. Others imagined the plate buckling like a sheet of paper pushed into a wall. Then a third idea showed up and changed the vibe completely. This new theory says the Indian plate is delaminating, which means its top layer peels away and props up Tibet. At the same time, the heavier bottom layer sinks into the mantle, the hot semi-molten layer beneath Earth's crust. Scientists can't drill that deep to check, so they followed a clue instead: helium leaking from Tibetan hot springs. Helium-3 is incredibly rare and mostly comes from deep inside Earth, and helium-4, forms closer to the surface. When researchers measured gases from hundreds of springs, they found helium-3 leaking out in northern Tibet. It means that the mantle sits dangerously close to the surface there. Farther south, that signal disappears. So it most definitely means that the plate hasn't fully split yet. But we have earthquake patterns that line up with the same story, so it looks like India isn't just pushing mountains up. It's peeling itself apart from the inside while doing it. All these tectonic processes fit in well with the new massive global stress map. It shows where the planet is holding it together and where it's dangerously close to rupturing. Scientists built it from over 100,000 real stress measurements taken from boreholes, earthquakes, and field tests, which is more than double what we had less than a decade ago. Stress here means the invisible push and pull forces inside Earth's crust, the same forces that quietly load faults for years before one bad day turns into an earthquake. This map doesn't just help explain earthquakes, but also not to mess things up ourselves. If you drill a tunnel, inject carbon underground, or build a geothermal plant without knowing which way the rocks want to snap, you're basically poking a sleeping dragon. Engineers use this stress data to decide how to angle wells and tunnels so they don't accidentally cause failures. Basically, we're finally getting a live dashboard for Earth's breaking points, and that's a big deal when you live on the surface of a restless planet. For a long time, we treated continents like rigid boards floating on soup. Now they look more like stressed muscles, flexing, tearing, healing, and tearing again. It shows that the planet under your feet isn't finished. It's still under construction. Darkness comes right at noon. What is it? The end of the world? Are you getting blind? Is some kind of giant asteroid moving toward Earth? Oh, don't worry. It's just an eclipse, a cosmic event on a planetary scale that isn't scary at all. It's a moment when the moon passes in front of the sun and the planet plunges into darkness for a short time. When this happens, we're not surprised, as scientists usually report on an eclipse several months in advance. With the help of astronomical calculations and mathematical models, they predict the positions of the sun and moon for many, many years ahead. But what happened to people in the past? 100? 500? 1,000 years ago? A farmer goes to work in the field and suddenly the whole area is plunged into darkness. He knows it's morning, but what's happening? Or sailors who travel the seas and oceans and suddenly notice that the horizon and the sky are getting too dark, as if someone had switched off the light. Imagine the primal horror they felt. But in reality, people didn't panic. Even before the invention of computers, giant telescopes, and satellites, people could predict the time of an eclipse in advance. How did they do it? People in the past were much smarter than some of us think. Let's see how they performed astronomical calculations using the example of the Maya civilization and their famous eclipse calendar. So in case you didn't know, the Maya are an indigenous people of Mesoamerica who lived in southern Mexico, northern Belize, and Guatemala. By the way, the word lived is not very fitting. These people are still alive. At the beginning of the 21st century, more than 5 million people spoke 30 Maya languages. Before the Spanish conquest, this civilization was one of the most advanced and complex in the world. The first Maya people appeared here as early as 1500 BCE. By 200 CE, the Maya had already built entire cities with pyramids, courtyards, temples, and infrastructure. The Maya were known for their calendars and astronomical predictions. Many of you have probably heard of the Mayan calendar, whose chronology ended in 2012, so a lot of people thought the apocalypse would start that year. Fortunately, nothing happened. Another Maya invention was the eclipse calendar, which helped these people predict eclipses. For a long time, scientists couldn't figure out how this calendar worked, but now they finally have the answer. It all began with the Dresden Codex, a book from the 11th or 12th century. It has 78 pages made of bark paper and contains knowledge about astronomy, astrology, the seasons, and medicine. It was one of the few books that remained intact after the Spanish conquest of Maya territory. The dates of eclipses used to be very important to people. But why? Did they want to take a day off on that day and have parties? Something like that. Only those parties were scary, dark, ancient rituals. And there was definitely nothing funny about them. The Maya assumed that the moment when the light of the sun was obscured by the moon was some kind of sign from the mythological creatures they worshipped. It was dark in the middle of the day, and the Maya used this time for their sinister rituals. They hoped these actions would please the deities, bringing good harvests, protection from enemies, renewal of nature, or other blessings. We won't go into details. The only important thing is that the Maya wanted to know the dates of the eclipses to prepare for the rituals in advance. For this purpose, they created the eclipse calendar. One of the tables in the Dresden Codex shows 405 lunar months. One such month equals one full orbit of the moon around the Earth, which is about 29 days. The Maya priests used these calculations to predict eclipses for about 700 years ahead. With the help of this calendar, they knew the day of the eclipse. However, modern scientists could not understand how the Maya used this thing. But recently, they found the answer. So, the Maya observed the moon and the sun every day. By observing how the moon moves across the sky, they figured out that it takes about 29 days to pass from one new moon to the next. Then, the Maya noticed that sometimes the moon blocked the sun, and those eclipses didn't occur at random, but in certain cycles. They created a large calendar with numbered lunar months, 1 month, 2 months, 3 months, and so on up to 405 months. During some months, the moon completely blocked the sun, and during others, only partially. The Maya noted exactly which days these eclipses happened. They recorded the moon's position for 405 months. With these notes, they could predict where the moon would be for the next 405 months, and then the next, repeating for hundreds of years. In simple words, they started the calendar anew after passing this deadline. At least, that's what modern scientists thought, but it was a mistake. The moon doesn't orbit the Earth in exactly the same time every month. Some months it takes a little longer, some months a little shorter, just a few hours more or less than the last orbit. Of course, such changes in the schedule were insignificant, but there were many of them, and this made the calendar incorrect. Imagine that you're only a minute late for a meeting with your friends. It's okay. But if you've been running late for 3 months, then you've already got about a 90-minute delay. On the Mayan calendar, which showed 405 months, there were many more of those extra hours. If the Maya always used the last number from one table to start the next one, their eclipse predictions would slowly become wrong. The mistakes would grow bigger each time they reset the table. Instead, the Maya probably began a new table at the 358th month of the old one. In this case, their predictions for when the sun and moon line up would only be about 2 hours and 20 minutes too early, which is very accurate for that time. If we compare the ancient table with what we know today about eclipse cycles, we'll find that this method would let the Maya correctly predict every solar eclipse seen in their lands between 350 and 1150 CE. These small corrections kept the table working well for a very long time. Scientists are sure that with these updates, the table would stay accurate for centuries, with mistakes of less than 51 minutes over 134 years. This shows how advanced Maya math was. It also reveals how deeply the Maya connected their lives and beliefs to the movements of the sun, moon, and stars. We do a similar thing when we have a leap year. February usually has 28 days, but every 4 years it gets an extra day, making 29. Earth goes around the sun not in exactly 1 year, as we usually think, but in 1 year plus about 6 extra hours. Because these extra hours add up over time, after a few years they become a whole extra day. To keep our calendar correct, we add this extra day to the end of February. This day is called Leap Day. This leads to small time errors, so we consider them in a leap year. The Maya did about the same thing with the eclipse calendar. But how did they choose the reference points for their astronomical calculations? We don't know. They did it without computers, telescopes, or other modern technology. They were just very good at observing nature. By the way, a similar system of cycles made people believe that the end of the world would happen in 2012. The Maya created a calendar that began in 3144 BCE and ended on December 21, 2012. The Maya saw this as the date of ending the old cycle and starting a new one. But our modern culture has turned this point into the end of the world. In addition to calendars, the Maya built unique architectural structures. They invented one of the most advanced writing systems. They were also big fans of liquid chocolate. They grew cocoa trees, then plucked the beans, dried, ground, and mixed these crushed beans with water. They warmed it up and got a frothy and very bitter drink. To make it sweeter, they added honey to it, but they could also throw chili peppers and other spices in there. Maya did many interesting things, but this is a topic for another video. For eons, the Red Sea has separated the continents of Asia and Africa. They're close enough to wave at each other, but far enough that moving between them requires planning. Ferries do the job, but it's time for something better. That's why engineers have envisioned an ambitious mega project of tunnels and bridges that will not only link the two continents, but also reshape the region forever. Millions of years ago, the Arabian landmass slowly drifted away from Africa, opening a watery scar that we now call the Red Sea. This place is famous for its crystal clear water that looks filtered even when it isn't, as well as for coral reefs that seem to be painted by an overachieving artist. Let's zoom in on one specific location, the Strait of Tiran. Every ship headed toward the upper ports squeezed through this one busy hallway. On the one side is Egypt, the Sinai Peninsula, rugged, golden, and sprinkled with resort towns. On the other side, it's Saudi Arabia, the Tabuk coast, where quiet desert hills stroll right down to neon blue water. The distance between them looks tiny on a map, almost like someone forgot to connect the lines. That's because the strait is only about 8 miles from peninsula to peninsula, close enough that on a clear day you can sometimes see the opposite shoreline. It's a busy gateway, and it's the exact gap designers want to turn into a direct road and rail link. So what are they actually trying to build? The idea is to create one continuous route between the Sinai Peninsula and the Tabuk coast. Engineers are still deciding whether it should be a bridge, a tunnel, or a hybrid, the combination of two. The problem is under the water. Near the shore, the bottom is shallow enough to support strong columns, but as you move farther out, the seabed drops quickly until it reaches about 900 feet. It's almost like walking off an underwater cliff. That sudden plunge is too deep for standard bridge supports. The design has to adjust to the landscape instead of forcing one shape across the whole gap. If they go with a bridge, the builders would place huge steel tubes called caissons on the seafloor. Think of them as giant metal buckets. Once they're in position, the water gets pumped out so crews can build a dry foundation inside. Concrete turns that space into a pillar rising from the seabed. The floating cranes drop long road sections between those pillars like puzzle pieces. It works well in shallow areas, but anchoring becomes difficult in deep waters due to high pressure, soft ground, and strong waves. Tunnels avoid this by going under the problem, literally. Crews can send tunnel boring machines called worms, or they can build submarine-sized tunnel segments on land and sink them into place. It's the same trick used in the Hong Kong-Zhuhai-Macau megalink, which proves it works even in busy, deep water. Now, people might look at the map and think, 8 miles? That doesn't sound so bad. In reality, it's nothing like tossing a giant tree trunk over a river and calling it a bridge. Cars, buses, and trains need those long, slow, friendly ramps that don't feel like a roller coaster. By the time you build those ramps on both sides, the whole thing could stretch to nearly 20 miles. That puts it in the same club as giants like the Chesapeake Bay Bridge Tunnel in the US or the King Fahd Causeway between Saudi Arabia and Bahrain. But it's not just the scale or unpredictable seabed that makes this intercontinental project challenging. There's also the climate. Temperatures regularly pass 100 degrees Fahrenheit. Concrete dries faster than planned, so crews have to cool it or work in shorter windows. Steel stretches in the heat just enough to make precise work annoying. And workers themselves cannot stand in direct sunlight for long without feeling like a baked potato. On top of that, the salty sea air chews through metal quicker than most people expect, so the whole structure needs tough protective layers and regular checkup. If this project gets the green light, you're looking at a timeline of several years. A good comparison is the Øresund link between Denmark and Sweden. It's only about 10 miles long and still took around 4 years to build, in an environment that is much easier to handle than the Red Sea. Then there's the price tag. Early numbers land around $4 billion, but that feels more like a starting guess than a final bill. If they run into problems, that figure will almost certainly climb. There's also one other problem that must be brought up: swimming right under the surface. The Strait of Tiran is home to dolphins, rays, sea turtles, and even sharks, including harmless reef sharks that glide around like they're protecting the beautiful, colorful corals below. These reefs aren't just decoration, they're some of the healthiest in the entire Red Sea. Scientists say that in parts of the northern Red Sea, some corals tolerate higher temperatures than many others around the world, which makes these reefs especially valuable from a climate resilience perspective. That means even a single mistake during construction could cloud the water with sediment, and that alone can smother corals like dust settling on wet paint. The same goes for noise, drilling, and ship movement. Reefs can't exactly move away if annoyed like fish can. Once they're damaged, it can take decades for them to grow back. That is, if they grow back. To avoid that, planners have to build in ways that keep the water as clear and calm as possible. Construction zones may need silt curtains to stop sediment from drifting away. Heavy equipment might have to avoid areas with dense coral clusters. Some sections could lean more toward tunnels instead of pillars to leave the seabed undisturbed. Every decision has to match the underwater map, not just the one on land. On top of that, the whole project would need constant supervision from scientists and inspectors. They would have to check how cloudy the water becomes and how marine animals behave during the work. If something looks off, the only responsible move is to slow down or change the method, instead of just rushing to finish faster and leaving the reef to pay the price. But if everything finally clicks into place, the payoff is massive. Right now, if you decide to skip the ferry and stay on land, the map punishes you. You have to loop all the way around the top of the Red Sea, through other countries on a drive more than 1,000 miles. All of that just to cross a stretch of water that is only a few miles wide at its narrowest point. It's like walking around the entire block just to knock on your neighbor's door. A permanent link would change this. Travel time drops, ports on both sides become easier to reach, and a drive from Africa to Asia suddenly feels as normal as crossing a long highway bridge. Not to mention the coolest part, which would be the view if they decided on the hybrid version. You begin your journey on the Sinai side, with the desert behind you and the Red Sea ahead. Instead of waiting in a ferry line, you roll onto a rising ramp while the water glimmers below. The road dips into a tunnel under a busy shipping lane, and before long, you're back in the sunlight on the other side, now on a different continent. The train version could feel even smoother. You find your seat, the doors close, and the train glides toward the crossing without any stop-and-go traffic. It slips into its own tunnel section, runs quietly under the sea, and pops back up on the Asian side before you have even finished scrolling your feed. For tourists, that could mean more resorts, more quick weekend trips, and a brand new continental hop that becomes a must-try experience. For delivery trucks, every hour saved is money earned. Even local towns would feel the change. They'd get more visitors, more trade, and bigger profits. A link like this doesn't just connect land, it connects economies, ports, and everyday life. And that's a giant opportunity, as long as the underwater world stays protected. The country's authorities are hiding something from you. They don't want ordinary people to ever find out the truth. You can see a lot of fake photos and false locations on the internet, but almost none of them are true. So what secret are they keeping? You definitely don't expect to hear this. They're hiding a tree. But it's not just a tree. Money grows on its branches. Can you believe it? Of course not, it's a joke. But the truth is, America does protect the oldest tree in the world, and its name is Methuselah. You can Google it and you will find a lot of fake pictures and some old gnarled aspens. Real photos of Methuselah are quite rare, and its location remains a mystery to this day. It's known to grow somewhere along the Methuselah Trail in the Inyo National Forest in California. It's a bristlecone pine tree, and its age is more than 4,600 years. Imagine how cool it would be to touch the trunk of that tree and feel all those thousands of years of history. Only it's not cool. This is the reason why the country is hiding its location. If thousands of tourists touched the tree and picked up small pieces of its branches, it wouldn't last even a month. Many trees in this area are pretty weak right now and suffering from drought and all kinds of bad insects. So Methuselah is also in danger. Don't touch or approach it, even if you find out the location. The tree was discovered by dendrochronologist Edmund Shulman. A dendrochronologist is a scientist who studies the rings of ancient trees. But more on that later. So Shulman discovered the tree in the middle of the previous century, and over the past 50 years, it has become shrouded in rumors and legends. But how did Shulman know it was the oldest? In 1957, he took a core sample and studied the tree's annual rings. You see, every year, a layer forms inside a tree, resembling a ring. But scientists don't cut the trunk, don't worry. They extract a piece as thick as a pencil, and that's enough. The more layers, the older the tree is. So, Shulman counted Methuselah's rings and found out that it's been growing for more than 4,600 years. This means it's even older than ancient giant redwoods, which were considered the oldest trees on the planet. In 1958, Shulman told the story about the existence of Methuselah and posted its photo in National Geographic. From that moment on, the tree became popular. Many people wanted to pluck a cone or twig from it, so the authorities forbade publishing information about the location of the tree. Later, other scientists examined Methuselah's rings and suggested it could be younger, though some rings were too faint or damaged to count. In any case, it remains the most ancient tree on Earth, officially confirmed that is. But it wasn't always like this. Back in 1964, a geographer, Donald R. Curry, stumbled upon a tree called Prometheus, which was about 5,000 years old. And you know what he did? He just cut it down. There are many theories about why he did it. The tool for getting core samples was broken, or this guy didn't know how to use it, but the result was sad. The tree didn't survive. Hopefully nothing like this will happen to Methuselah and it will live a long life. But why are scientists so worried about it? Yeah, it can tell a lot about the history of our planet. But is there another reason? There's a theory that this tree could live forever if no one cut it down, and droughts or parasites didn't destroy it. So basically, Methuselah is like nature's fountain of youth. Imagine if we could use that trick on people. Okay, now we know what the US hides, but do you know what Australia keeps secret? Not just a tree, but an island. Even if you were allowed to visit the island, it wouldn't be easy for you to get there. The island is located between Australia and Antarctica, somewhere in the middle of the ocean. But it's unlikely that you would get such permission. The fact is that Heard Island is completely untouched by humans, and Australia wants to keep it that way. You'll find little reliable information about this island on the internet. All we know is that the island has 2 active volcanoes, Australia's tallest mountain, and several glaciers. But you know what the coolest thing is? It's home to animals you won't find anywhere else. The island's closed ecosystem preserves creatures that might have never seen people. The next island is quite famous and is located in Brazil. The authorities don't keep it a secret, but they protect it from tourists. Even if you had permission to visit this place, you probably wouldn't want to. This is Snake Island, and its name speaks for itself. This piece of land contains the largest concentration of venomous snakes in the world. Those are golden lancehead pit vipers. One bite of this snake is critically dangerous for a person. The snakes are all over the place there and have almost no competition from other animals. Only specialists capable of handling these reptiles can visit the island. Lots of secret places stay off limits because humans can mess them up without meaning to. It's not that we're bad, it's just that even being there can change tiny invisible parts of nature. And here's a great example of the kind of destruction we can trigger. You've all seen photos of ancient cave paintings with horses and bulls. One of the most famous of such caves is the Lascaux Cave, which is located in France. On the walls inside the cave, people found more than 600 drawings and about 1,500 engravings. The 20,000-year-old drawings depicted different animals. Scientists opened the cave to the public, and this led to a disaster. Too many people came to see the cave, and it messed up the cave's ecosystem. Then a fungus showed up and started spreading over the walls, ruining the old drawings. It was a tragedy for the scientific world. The cave was quickly closed to visitors. Now, only a small group of archaeologists can enter it. No one knows when or if the cave will open again. Those glimpses of human history from the first European settlements might be lost to the public forever. Our next secret location is in Svalbard, Norwegian archipelago. This is the Svalbard Global Seed Vault, a massive storage vault that can keep 4.5 million seeds of different types. The authorities say that the seeds are stored there to preserve the population in case of a local disaster. But a lot of people think they're tucked away for the apocalypse, ready to help us replant Earth if everything goes wrong. But why, of all countries, did people decide to store seeds here? Because of Svalbard's cold, dry climate. The weather conditions here are ideal for seed preservation. The vault is well guarded, it's classified, and no one can get inside except for authorized persons. All our secret places are connected with nature. An island, a forest, a cave. But how about finishing the video in the city? It's in plain sight, but it hides a secret room that is impossible to enter. In Atlanta, Georgia, inside a museum with top-notch security, the secret Coca-Cola recipe sits locked away in a massive safe. What? Yes, this is probably one of the most guarded secrets in the world. Money, diamonds, ancient artifacts. None of them get the kind of protection a single sheet of paper with the Coke recipe does. This secret has been kept there for more than 125 years. The unique storage design and security system make burglary almost impossible. You can visit a specialized museum and see the door to the vault, but nothing else. Sure, it sounds a little crazy to guard a single piece of paper, but then again, this drink has made the company billions. Coca-Cola has been one of the world's favorite drinks for over a century, and it's still raking in massive profits, so it's not surprising that its recipe is kept so secret. The pyramids will make you say, wow, just look at the size of these things. No wonder people joke about ETs lending a hand or a tentacle. It's like some ancient construction magic. But hey, indigenous people also proved themselves magicians of architecture. Long before skyscrapers or cranes, they built cities and made wonders that confuse engineers even to this day. And one of those feats is when they famously moved an 11,000-pound tree trunk more than 100 miles just to make it stand upright. If we could go back around 900 years across the Mississippi River where St. Louis, Missouri stands today, we would witness something magnificent. This land was home to an indigenous metropolis called Cahokia. Back then, it had tens of thousands of people with plazas and large wooden structures for ceremonies and gatherings. This was the largest city north of Mexico. At its center was Monk's Mound, a huge platform of packed soil taller than a 10-story building and made entirely by hand, with millions of baskets of earth and clay. So when you can make something like that, why stop there? The people of Cahokia also constructed huge wooden posts, which may have served as solar calendars, ritual markers, or symbols of spiritual connection. Some of those were as tall as modern houses, but they weren't just random poles for showing off. They were arranged in massive circles that archaeologists now call wood henges, which are kind of like ancient observatories. By tracking where the sun rose and set, they could figure out the longest and shortest days of the year. They also marked the 2 times when day and night were equal. This was super helpful for farmers when deciding when to plant and harvest. Plus, it helped them keep their calendars synced with the sun for their seasonal ceremonies. Among those monuments was a very special one, a colossal bald cypress trunk, later named the Mitchell Log. Unlike the wood henges, this wasn't part of a circle or calendar. It ended up standing alone, probably right in the ceremonial plaza. Archaeologists believed it served as a symbol of power or spirituality, something like a wooden obelisk rising above the city. Some researchers even suggest it might have represented an axis mundi, a kind of world pole that stitched together everything the Cahokians believed existed. To them, the universe was layered. Above was the upper world, home of the sun and the moon and the forces that ruled the weather and time. Below lay the lower world, a watery realm of chaos, spirits, and transformation. And between them, the middle world. It's where we are, hanging out with bears and buffalo. Monumental posts like the Mitchell Log may have marked the connection point between all 3, becoming a place where spiritual power could flow between the worlds. At least that's what we think they believed. But whatever its purpose was, that's not the wow part. It's that the log was nearly 59 feet long and weighed around 11,000 pounds. That's roughly the weight of 2 full-sized pickups, such as Ford F-150s or Chevrolet Silverado 1500s. And even more shocking, that kind of tree didn't even grow near Cahokia. Scientists found it had come from over 110 miles to the south, hauled all the way without wheels, cranes, or engines. So how on earth did they do it? Well, to understand how this was even possible, we have to look at what tools and knowledge the Cahokians actually had. We know they didn't have carts, metal tools, or animals like horses or oxen to pull heavy loads. Those simply didn't exist in North America yet. And even with the power of teamwork, that's still 2 pickup trucks. The kind of task that seems challenging even with modern technology today. And the first one, while incredibly cool, is probably less likely to be true. The theory is fairly simple. They hauled it over land. Just think of hundreds of people pulling something so heavy through forests and wetlands step by step for more than 100 miles. With ropes, rollers, and determination. They would have had to cut paths, build makeshift bridges, and find clever ways to keep the trunk moving without breaking it. It sounds impossible, but then again, so does stacking 2.5 million stone blocks to make the Great Pyramid. Yet somehow, humans did that too. The second theory is more practical and requires a bit of out-of-the-box thinking. They floated it over a river. The Mississippi River system is enormous, with a web of connected rivers and channels linking the southern cypress swamps to Cahokia's doorstep. The Cahokians probably already used these routes for trade, so moving a tree by water wasn't out of the question. They may have floated or rafted the cypress through the Mississippi's sloughs and backwaters. By hollowing out a few smaller logs to make rafts or using bundles of reeds to help with buoyancy, they could have kept the trunk floating while guiding it downstream with some poles and ropes. Just imagine the logistics of that. It's efficient and smooth because once the trunk is floating, the water is carrying almost all of its weight. Smaller teams would just need to steer it around the bends with poles and ropes instead of trying to lift it the whole way. It would still take an incredible amount of planning and precision. If nothing else, the Mississippi wasn't exactly calm. It had shifting sandbars, hidden snags, and powerful currents. If they had chosen the wrong time of year or let it jam against a bank, the log could have been lost entirely. But wait, how can scientists tell how far it traveled and when it was cut? Remember, they claimed this was hauled ages ago. This part isn't a theory, it's scientifically proven. The researchers started with a test called strontium isotope analysis. Strontium is a natural element found in rocks and soil, and each region has its own unique mix. Trees soak it up as they grow, locking that chemical signature into their wood. By comparing the strontium in the Mitchell log to modern samples from around the area, The team figured out it came from more than 110 miles south of Cahokia, likely near what's now southern Illinois or northern Arkansas. They also figured out when the tree had been chopped down. They used the same method we use for fossils, called radiocarbon dating, but with an interesting twist. Every year, a tree grows a new ring, kind of like a line on a calendar. So 9 centuries ago, a huge burst of energy came from the sun. When that radiation reached Earth, it slightly changed the air and plants everywhere. The trees that were alive back then recorded that change in one of their rings. Scientists today can spot that special ring and say, aha, this one grew during a solar storm we already know happened centuries earlier. That spike works like a timestamp, so by counting the rings that grew after it, they can tell exactly when the tree was cut down, and that year was 1124. And this isn't the first time researchers have used this trick. The same type of cosmic ray timestamp has been found in trees worldwide. In Japan, it helped date an ancient cedar that had recorded a solar storm in 774 CE. In northwestern Europe, they used it to determine when Viking ships were built. Over in Newfoundland, it helped researchers prove that Vikings actually got to North America around 1021 by matching a cosmic ray spike found in the wood. When we see something genius in architecture, we usually assume it came from advanced technology and complex math. And that's true. Only here, the technology was simpler and the math was practical. The Cahokians didn't need engines or blueprints. They used what they had and knew how to use it well. If it's true that they achieved this incredible feat using water, it means they mastered the rivers the same way the Egyptians mastered the desert. They learned how to work with nature instead of against it. Or maybe you support the first theory. Hundreds of strong men patiently crawling through the jungle. Let me know in the comments, and thank you for watching.
You know, our planet can be absolutely breathtaking if you know where to look. From Greenland's green waves to deserts glowing like molten gold, the planet looks like living art. But there's something even better than knowing what to look for. It's knowing where to look from. For example, from a few hundred miles above the ground, where satellites are, so you can see faces in deserts, hearts in sand, spirals, skulls, and mirror lakes flashing sunlight straight back into space. These are some of the weirdest things you can see from space. In the middle of the Sahara Desert, satellites once caught sight of something meant to scare visitors from outer space. It's a colossal skull staring right up at the sky. Its hollow eye sockets, long nose ridge, and cracked outline looked eerily human, almost as if something enormous had been fossilized beneath the sand. The photo spread quickly online, with people wondering if it could be the remains of an ancient giant, a lost monument, or even evidence of a civilization swallowed by the desert ages ago. But in this case, the truth is climactic. The skull is no fossil or ruin. It's the remains of an ancient volcanic pit carved out by a massive eruption hundreds of thousands of years ago. Over time, relentless desert winds carved away the softer layers of rock, while the tougher ones held firm, leaving behind ridges, pits, and hollows. When sunlight hits it just right, those shadows fall perfectly into place, completing the illusion of a face. Down in the Namib Desert, there's an incredible natural wonder. Fairy circles, roughly circular, bare patches in the grasslands. From above, it looks like a perfect circle cut into the sandy landscape, surrounded by shimmering golden dunes. Some people thought it might be an ancient crater, or even a ritual site hidden by shifting sands. Others guessed it could be the mark of a long-extinct lake, or a meteorite that fell millions of years ago. But the real explanation might be even more fascinating. The formation lies in a region famous for fairy circles, thousands of mysterious round patches scattered across Namibia. For decades, no one knew what caused them. Then, researchers discovered the patterns seemed to emerge naturally, shaped by wind, roots, and even termite colonies competing for scarce water. Over time, these small circles can merge into larger perfect rings, like the ones satellites now call the heart of the desert. The desert is a sight to behold on the ground, but from space, the sheer size of it will make you pause. In the heart of the Canadian Badlands, satellites can see a formation that strikingly resembles a human face, seemingly resting sideways in the soil. This quirky landmark is called the Badlands Guardian by locals. The coincidence is also great. Imagine if you could see a guy wearing a Roman helmet while looking at Italy from space. The contours create what appears to be a forehead, an eye, a nose, and even lips. Some folks amusingly insist that they can see a pair of headphones resting in the ear. For years, people speculated about its origin, pondering whether it was an ancient artifact or a colossal sculpture hidden beneath the surface. However, unless we are proven otherwise, we must believe that the Guardian is actually a natural formation, shaped by the relentless forces of wind and rain over millennia. But the headphones are real. Okay, that's a joke. They're simply a road and an oil well pad, constructed long after nature had woven this artwork. Now, what makes this illusion even cooler is the play of sunlight. Depending on the angle, shadows play around in the gullies and ridges, making the face look almost real. It's an amazing natural effect, a mix of light and erosion. You could say it's our brain's knack for seeing faces everywhere. But come on, just look at it. Near Egypt's Red Sea coast, satellites once revealed something that looked almost too perfect to be natural. A massive spiral design carved into the desert floor. Thousands of sand mounds and depressions arranged in hypnotic precision, stretching wider than a city block. Well, let's speculate. It could be something left after visitors from other planets, or maybe a forgotten symbol from an ancient civilization. Now, theories spread fast. Some said it might be a secret military installation or a message meant for the skies. Others wondered if it was another one of those unexplained desert geoglyphs, like the Nazca lines in Peru. But when artists came forward, the mystery got solved. It's a bit anticlimactic. The spirals turned out to be part of Desert Breath, a massive art installation built back in 1997 by 3 artists who wanted to make something that could only be fully seen from above. Over 1 million square feet of sand were sculpted into smooth cones and hollows, designed to slowly fade away over time as wind reclaimed the land. Ironically, that's exactly why it still fools people today. From orbit, the desert's light and shadows preserve its shape perfectly, making it look brand new every time the sun hits it. It's one of those rare creations where art, time, and nature work together. The pattern is still mesmerizing, and if visitors came from above, they'd be sure to admire it, baffled as we were. Meanwhile, far out on the coastal plains of Peru, satellites revealed something absolutely unbelievable. Etched into the desert are enormous figures. From the ground, you can't see them properly, but from above, they turn into another large-scale art. There's a hummingbird, a monkey, and probably the most famous of them all, a spider. The 8-legged creature is so perfectly drawn, it looks like it's crawling across the earth. The spider alone spans about 150 feet from leg to leg, and what's strange is that it matches a species found deep in the Amazon rainforest hundreds of miles away. So, how could people 2,000 years ago know what it looked like so clearly and carve it into the ground with that kind of precision? Well, theories flooded in. Some claimed the lines were messages to deities watching from the heavens. Others thought they might mark the paths of underground waters or serve as ritual sites to call for rain. But the leading explanation today is both clever and beautiful. The Nazca people scraped away the dark gravel coating the desert to expose lighter soil beneath, creating enormous white outlines that have survived for centuries thanks to the desert's dry, windless climate. The Nazca lines were never meant to be seen from the ground, at least not by wingless humans, but now we have satellites and it's breathtaking. Now, over in China's Gobi Desert, satellites once captured a series of bizarre geometric patterns etched into the sand. Huge grids, bright white lines, and crosshatching that go on for miles. When they first popped up on Google Earth, they went viral. People thought they were looking at gigantic runways, coded symbols, or even the remnants of a lost civilization. Some even speculated they might be a message meant for visitors from space. Well, eventually, experts figured out that those massive lines were actually satellite calibration targets used by China to check the accuracy of their military and remote sensing satellites. Those bright white patterns reflect sunlight really well, helping instruments measure distance, focus, and orientation from way up in orbit. The shapes are really large. Some are over a mile wide and set up in perfect right angles that would impress any perfectionist. They're made for cameras thousands of miles above, not for human eyes. From the ground, they just look like stretches of gravel and stone, but from space, they turn into some of the most precise targets ever created by people. There's more, but that's for some other video. For example, the Eye of the Sahara in Mauritania, a massive 25-mile-wide spiral that looks like a portal burned into the desert. Or the boiling Danakil Depression in Ethiopia, glowing in neon golds and greens like it's from another planet entirely. It's kind of cool that you can observe works of art just by zooming in a bit, like it's all just a matter of perspective.
Do you know how much gold has been mined by humans throughout history? About 216,000 tons, and 2/3 of this amount was mined after the 1950s. Different countries, different times, thousands of different people involved. But what if you found huge deposits of gold in one place? What if a giant gold ore deposit was discovered? No, not just giant, but super giant. This is exactly what was found in China. A group of geologists discovered about 40 gold veins with about 330 tons of gold ore. But that's not all. 3D modeling has shown that even more gold lies underneath. At a depth of about 9,800 feet, there may be several hundred more tons. In short, there is a chance that they will discover deposits with about 1,100 tons of gold. Can you imagine how much that is? If not, that's about $83 billion. Wow! Experts say that this deposit contains approximately 4.9 ounces per ton of ore. It seems that this is negligible, but in fact, it's a high indicator in gold mining. Usually, 0.35 ounces per ton is awesome. If all calculations turn out to be correct, it will be the largest gold mine in the world, even bigger than the South Deep mine located in South Africa, with its 1,025 tons of gold. Everyone is worried. Everyone is happy. Gold, gold, gold on their minds. Everyone wants gold. Everyone buys gold. Gold is rising in price. Gold is more reliable than Bitcoin and cash. Gold is associated with wealth and luxury. Gold is always a valuable and profitable investment. But hold up. Why is it so? Why do people go crazy over some shiny metal? The fact is that gold has both practical and psychological value. For centuries, gold has represented power, prestige, and wealth in different cultures. It seems we're born in a genetic memory that gold is valuable. Think of how many problems gold has brought to literary heroes and how many gold-related adventures we've seen in movies. Gold makes people happy and greedy, cruel and intimidated. That's why so many people love it. Yes, it glitters, it's beautiful, but it's also practical. Gold doesn't rust, it doesn't corrode, it can be stored for a long time, and it doesn't deteriorate. It's literally a reliable investment. All other savings may lose value because of crises, but gold remains unchanged. The only problem, it can get stolen. In addition to jewelry making, gold is used in electronics, medicine, aerospace, and many other industries. Bitcoin has a value because of the public support of people around the world. Money has value thanks to the support of authorities. Gold has value on its own. It's tangible and visually appealing, and its worth is also supported by people's centuries-old belief in its enduring value. But never let gold cloud your mind. Many people lose their honor and even their minds over it. Avoid this trap. It's just a shiny piece of metal. There are other precious metals in the periodic table: palladium, silver, copper, platinum. Why is gold number 1? Cheaper metals such as copper, iron, lead, and aluminum corrode and rust. Aluminum is also not durable. Platinum and palladium are more expensive than gold, but they're too rare and difficult to mine. You won't make many coins out of them. Silver is softer than gold. It tarnishes, scratches, and deforms. And, well, to be honest, gold is more beautiful. But there is another reason why gold is so expensive. It's quite difficult to get. Gold mining is a very laborious and long process. In movies or documentaries, you might have seen people standing at the mouth of a river, collecting silt and clay, sifting it through gauze and small nets, and finding gold particles there. That's one of the methods for how gold is mined. You have to work hard to get just a few small pieces. How do they find gold? It used to be luck. Someone was walking along the shore and saw something glistening in the water. But today, gold detection methods are much more effective. Geologists know that gold is present in almost all rocks and soil, but its particles are so tiny that they're not visible. But when the concentration of gold is high and noticeable, work begins to extract it. Special geological teams are engaged in searching for these sites. When they discover gold, they drill wells, then take soil samples and decide if there's enough metal to carry out large-scale mining. Production depends on the deposit. If gold is in hard rock, miners drill holes, place dynamite, and detonate it. The explosion breaks the rock into pieces so they can extract the gold. But this is just the beginning of the work. After collecting large pieces of rock, workers take them to factories to extract valuable material. At the first stage, specialists break large pieces of rock into smaller ones. Using crushing machines, they grind the ore into tiny pieces, similar to gravel. This gravel then enters rotating drums filled with steel balls. The drums spin, and the balls grind the gravel into powder under pressure. This mass is then mixed with water and passes through special filters. After that, gold is extracted from the ore using chemical solvents and complex purification systems. It adheres to carbon, then is separated from it, followed by several additional processes, including electrolysis and further purification. At the end, the gold is melted and separated from impurities, then poured into ingots and sent to other plants for further processing. Yes, it's a difficult and time-consuming process, and quite a long one. And it's not always profitable. You can find a deposit of precious metal, but it will be too expensive to extract it, and the amount of gold there won't be enough to make the effort worthwhile. Only 10% of the world's gold deposits contain enough precious material to pay back for its extraction and processing. There are many areas filled with gold. Do you know how many of them are suitable for productive mining? Less than 0.1%. So this is probably another reason why gold is so valuable. But is there any other material that causes a lot of excitement? Oh yes, this material is called liquid gold. And this is helium. That's the gas used to inflate balloons. But this is not its main value. Helium is capable of reaching ultra-low temperatures, is superconducting, and is lightweight. Helium is used in medicine for diagnostics. For example, for magnetic resonance imaging. Helium cools nuclear reactors and maintains rocket fuel temperatures during launch. Divers breathe a mixture of helium and oxygen during deep dives to avoid diseases associated with pressure changes. Helium is crucial for the modern world. Another precious material is graphene. It's not just one of the most durable materials in the world, it's a highly conductive material. Heat and electricity pass through graphene easily, which makes it very promising for the development of what? Considering that graphene is also flexible, water-repellent, non-toxic, and has antibacterial properties, it's suitable for developing everything. Medical equipment, mechanical engineering, electronics, construction, logistics, energy conservation, space and underwater industries, and much more. Scientists believe that graphene has the potential to enable revolutionary new technologies that could change the lives of all people. Something similar happened with silicon. which is actively used to create semiconductors and rechargeable batteries. It's possible that without silicon, we wouldn't have smartphones, laptops, and other electronic devices. Graphene may also lead to a new technological leap. When the world switches to renewable sources of energy and uses electric transport, graphene can become technological gold. During tests, graphene batteries have shown that they charge more than 70 times faster than regular ones and last 3 times longer. At the same time, they're cheaper and environmentally friendly. Okay, that sounds cool, but where do we get this graphene? It's obtained from graphite, which lies in the bowels of the Earth. One of the largest graphite deposits is located in South Australia. 200 million tons of high-quality graphite. It sounds like it could be enough for the entire planet. Something is about to reshape the entire future of the West Coast. The coastline, the infrastructure, the whole map. Scientists fear there is not one but 2 big earthquakes coming, one caused by another. This wasn't even on the radar for most people, but new research is changing everything. For decades, everyone treated the San Andreas Fault and the Cascadia subduction zone like 2 separate monsters that just happened to live in the same neighborhood. They were powerful, yes, but independent. But now, scientists believe these 2 giant faults are mechanically linked, and one can literally pull the other into rupturing shortly afterward. Cascadia moves, San Andreas moves. San Andreas tears, Cascadia tears. And the potential consequences of that are honestly haunting. Scientists found evidence that it happened at least 10 times in the last 3,100 years. Earthquake, pause, earthquake. It comes from marine sediment cores, which are like time capsules pulled up from the ocean floor. Researchers analyzed layer after layer of seabed sediment and found doublets, paired debris layers created by 2 massive quakes happening so close together that the ocean barely had time to settle between them. That discovery takes us to the Mendocino Triple Junction, the geological troublemaker of the West Coast. It's the place where 3 tectonic plates crash and grind into each other like badly aligned gears. It's also the zone where the San Andreas meets Cascadia, which makes it the perfect place for these double quakes to form. The stress changes caused by a rupture in one fault travel straight through this junction and destabilize the other. It's benign when it happens to a bookshelf. When you move one book, 3 others shift. But when you think about it like a coastline with millions of people, entire cities, major infrastructure, it instantly feels terrifying. To many people who live on the West Coast, the San Andreas kind of feels like a California's problem, and Cascadia like an Oregon and Washington's problem. But when you understand that these 2 faults can essentially fire at each other, it stops being a local issue and becomes a continental one. A Cascadia megaquake alone can hit magnitude 9.0 plus, rip open 600 to 700 miles of seafloor, and send a tsunami roaring toward the Pacific coast. And it could just be the first quake, and then, maybe minutes later, the San Andreas snaps in Northern California. The shaking could ripple down the state like a zipper tearing open a jacket, and if it goes the other direction, it could be just as bad. If the San Andreas ruptures first, the intense stress redistribution can destabilize the Cascadia subduction zone. You could get the California quake first with buildings rocking, highways breaking, and power stations failing. And then, soon after, the ocean pulls back in Oregon or Washington. And the 20-minute countdown to a tsunami begins, a follow-up disaster. It's the kind of chain reaction you don't want even in a video game, let alone real life. This discovery also tells us something eerie about the earthquake in 1700. The one that sent a tsunami across the Pacific so huge that it struck Japan with no warning. Japanese fishermen called that wave the orphan tsunami because it arrived without any felt shaking. Only centuries later, scientists figured out that it came from the Pacific Northwest. But until recently, no one knew that the San Andreas might have felt that event too, and it possibly slipped or destabilized because of it. So, the whole West Coast may have moved together. And we've come to the scariest part. All this isn't about if, it's strictly about when. The faults have a rhythm, a pace, and a geological heartbeat. We've seen how they behave across thousands of years. We know what they did, and now we know they sometimes do it in sequence. The real fear isn't the first quake. California already expects a big one. The real fear is the second quake, the one that comes before you've checked on your family, before emergency responders regroup, before the power comes back, and before the dust settles. Even if you don't live on the West Coast, this matters for you too. The ports in California, Oregon, and Washington handle a massive chunk of America's imports. Knock them offline, and it's not just the coastline that feels it. The ripple hits the entire country and potentially the world. Grocery prices spike, supply chains freeze, gas availability dips, shipping timelines go nuts. The world is much more connected than any of us thought, and a geological double punch on the Pacific coast wouldn't stay a local disaster. It would spread, thread by thread, into everyone's life. So, those in power must prepare not for one giant rupture, but for two. Emergency plans, evacuation routes, response times, and power grid designs, all of it needs updating. Because nature has now shown us what even a single major rupture can do to a modern economy. It happened in Japan in 1995, on January 17th at 5:46 in the morning. The quake hit right by the northern tip of Awaji Island, only 12 miles from Kobe, a huge, busy city with about 1.4 million people back then, and another 2.6 million in Osaka nearby. The rupture ripped along the Nojima Fault for about 25 miles. That doesn't sound like much until you realize entire buildings can't survive that kind of sideways shove. More than 5,000 people lost their lives. 43,000 were injured. Nearly 400,000 buildings were irreparably damaged. This disaster hit one of Japan's largest industrial zones. And when you mess with a place like that, the shock doesn't stop at the shoreline. The damage was $200 billion US in losses, from smashed buildings and infrastructure and many businesses shutting down. Kobe's port just collapsed. Only 30% of the Osaka-Kobe railway lines worked. Part of National Route 28 literally vanished into the ground. Schools, hospitals, and municipal buildings, 85% of them took damage or were unusable. Fires broke out across Kobe, almost 300 separate incidents, burning the equivalent of 70 US city blocks and taking another 600 to 700 lives. Almost 100,000 people permanently left the region, 2.5% of the whole population gone in less than a year. And here's a detail that stuck with me. So many bridges failed that engineers suddenly had to confront how poorly older designs handled lateral shaking. Houses with heavy tiled roofs, built to fight typhoons, crumbled because all that weight sat too high. But the newer homes made after the 1981 building code revision stood. And that's when Japan realized that modern seismic standards were crucial to follow. Japan threw $58 billion US into restoring the region. Power came back in days. Roads and rail returned in 5 to 8 months. The main expressway took 21 months. The port was fully rebuilt in just over 2 years. And by then, all debris was cleared. Within 15 months, manufacturing jumped back to 98% of its old level. Stores reopened. By 1999, Kobe's economy reached roughly 75 to 90% of pre-quake levels. Japan overhauled its disaster management system entirely. They set up the Central Disaster Management Council and rewrote building codes. They upgraded everything from emergency drills to fire-resistant city layouts, and they launched the Earthquake Early Warning System that now gives Japan those precious few seconds before shaking hits. The same system that saved countless lives since 2007. But despite all this improvement, the Kansai region still sits on dangerous ground. The Roku-Awaji-shima fault system, the same one that snapped in 1995, still runs under them. The 2018 Northern Osaka quake and the 2024 Noto Peninsula quake reminded everyone that this threat didn't disappear. It just waits its turn. A future large event on that system could hit even harder simply because the region has grown more complex, more interconnected, and more economically loaded. So Kobe wasn't even a triggered double fault rupture, but it still broke a major industrial hub. reshaped a national economy, and permanently changed global shipping routes. That's why when scientists started talking about two joint faults firing off back-to-back in Cascadia and San Andreas, you don't even have to imagine the consequences. We already got a preview in 1995. For centuries, the whole world was wondering how the giants of Easter Island moved around. Maybe powerful chiefs ordered big groups of workers to haul them. Or the elite controlled special statue-making quarries. But now we finally know the people of Rapa Nui didn't drag their moai statues into place like lifeless logs. They made them walk. Scientists looked at nearly 1,000 moai, checked their shapes, proportions, wear patterns, and the gentle forward lean and curved base that many statues have. And then it struck them. Those details weren't accidents, but engineering. The forward lean shifts the center of gravity, and the curved base lets the statue pivot like a pendulum. Once the motion starts, inertia helps carry each step. Think of it like walking an enormous stone toddler using ropes and balance. To prove this right, the research team built a 4.35-ton replica. The real statues were around 13 tons, and some weighed up to 80 tons. With 18 people on the ropes, they walked the statue about 300 feet, about the length of a football field, in 40 minutes. That's faster and easier than dragging something flat across logs or rollers. The old roads of Rapa Nui also help the process. They're about 14 feet wide, and the way they curve inward makes them perfect to keep a statue steady while it walks forward. Every time the islanders moved a moai, they weren't just walking it, but they were literally shaping the road as part of the job. When you look at the island's landscape today, you can actually see these paths crisscrossing each other, sometimes running side by side like alternate routes. The ancient workers were likely clearing a stretch of ground, moving the statue a bit, clearing a bit more, then rocking it forward again in a specific rhythm. It looks like they spent just as much time prepping the road as they did moving the statue itself. So, the ancient Rapa Nui didn't need thousands of workers or modern machinery, and it all worked with just ingenuity, rhythm, teamwork, and clever design. Their transportation wasn't the only moai mystery. People knew the statues were meant to honor important chiefs, but no one could explain why the ancient islanders picked those exact spots for them. Most of the moai sit right along the coastline, almost like they're guarding the island. So a team of scientists took a closer look at those locations, and the answer turned out to be all about water. Easter Island's volcanic soil is super porous, which means it soaks up rainfall quickly. Because of that, there weren't enough rivers or streams, and the island ended up with very limited fresh water. Hundreds of years ago, the people survived thanks to groundwater discharge. Basically, water stored deep underground in layers of rock or soil called aquifers eventually rises up to the surface on its own. When that water bubbled up near the coast, it mixed with seawater, but the mix stayed fresh enough to drink. The locals collected it right from those coastal spots, and that's exactly where they built the moai. They weren't just decorating the coastline, they were marking the island's most essential source of fresh water. Now, most of the moai bodies were made from volcanic tuff, a soft, easily carved stone, and most of the statues were carved in one quarry inside an ancient volcano. In October 2023, a wildfire tore through the quarry, and everyone who cares about Rapa Nui got really concerned about whether the site would survive future disasters. So when a team of scientists arrived in January the following year, a local community group asked if they could document the quarry, just in case another fire damaged it for good. The geographers jumped at the chance and launched about 30 drone flights over the quarry. Flight after flight, they collected an incredible 22,000 photos. After that, they spent months running those images through computer software that stitched every piece together into a single, hyper-detailed 3D model. Now anyone in the world can explore Ranu Raraku, one of Easter Island's most important quarries, without even setting foot on the island. Of course, the 3D model isn't just an online tour platform. The team noticed that there were several workshops inside the quarry, and carving techniques changed from one site to another. So there wasn't one chief who told them how to do it, but rather each spot worked like its own workshop that was tied to a specific family clan. This could also be another proof that the Moai could move with far fewer people than anyone once believed, probably around 20 to 50. That's roughly the size of an extended family or small lineage group on Easter Island. Most statues were carved while lying on their backs from the top down. In the most common method, the carvers focused on the face first, shaping the eyes, nose, and mouth, and then carved the outline of the head and body around those features. The second method flipped that order. They carved the entire block into the basic shape of a Moai first and didn't add any details until later. And in a few rare cases, the carvers went at the stone from the side and worked straight into a nearly vertical cliff, which must have taken some great skill. And just when researchers mapped over 1,000 Moai and thought they knew them all, the island threw them a curveball. In the middle of a dried-up lakebed, a place no one expected anything, another statue appeared in 2025. It was the first statue found in a lakebed before, and it might not be the last. For at least 200 or 300 years, the laguna was almost 10 feet deep, so it would be impossible for humans to build or put a statue on the bottom. Scientists think the Moai are over 500 years old. It's possible that the Rapa Nui people who built them probably brought the statue here when the lake was dry in the past. The new find turned out to be slightly over 5 feet tall, which is smaller than the other statues on the island. As the region continues to dry out, the lakebed has started revealing what it's been hiding for who knows how long. More statues could be tucked under those thick reeds that grew over the lake for centuries. Now that the water has receded, scientists might be able to use ground-sensing tools to detect what's buried beneath the surface. While researchers keep studying the statues and solving their mysteries, nature is playing against them. A new study shows that by 2080, seasonal waves could push far enough inland to hit some of Easter Island's massive Moai statues. These stone giants have stood through everything: harsh sun, relentless wind, pounding rain, lichen slowly creeping across their surfaces, and even wildfires. But rising sea levels already threaten the island's coast, and the Moai now face a danger bigger than anything they've endured before. Researchers built a super detailed digital model, a digital twin of a bay on the island's southeast coast. They ran a bunch of simulations to see how different sea level rise scenarios would change the way waves move through the bay. The results of these simulations showed that waves could start reaching the site's 15 Moai by 2080, and then of the most recognizable and photographed statues on the island could end up flooded. This spot sits on a big ceremonial platform and draws more visitors than almost any other Moai spot on Rapa Nui. And the danger doesn't stop there. Dozens of other important cultural features nearby are also in danger. Ancient dwellings, petroglyphs carved into stone, burial sites, old rock gardens. Basically, the entire physical memory of Rapa Nui's cultural history. If the island doesn't manage these risks, it could even lose its UNESCO World Heritage status. Now that researchers understand the threat more clearly, they want to use this knowledge to help protect the island. Scientists hope to collaborate closely with local communities to safeguard Rapa Nui's cultural heritage for future generations. We've all thought about rewinding time, whether to fix that cringeworthy mistake or a sneak peek at next week's sports scores. But let's be real, those thoughts fade. For most of us, time travel is just a fun movie idea. But for astrophysicists, time travel isn't just sci-fi. It's a serious puzzle hidden in the fabric of space-time. And now, new models suggest the universe might just allow time to bend in ways that didn't seem possible. Humans were intrigued with manipulating time long before complex scientific models. In an ancient Hindu story, a king visits the heavens for minutes and returns centuries later. In a Japanese legend, A fisherman spends days in an underwater palace and comes back to find generations have passed. These are some of the myths that hint that time doesn't flow the same everywhere. And time traveling as a concept didn't just pop up from regret or curiosity, it also came from watching space. Time feels like one constant in our lives. It's always moving forward like a river. It flows forward and it's predictable. But when we zoom out, way outside of our planet, it's a different story. To physicists, time bends, stretches, and slows down depending on how fast you move or how strong the pull of gravity is. And that's not just a theory. It's measurable, proven, and built into the technology we use every day. For example, astronauts on the ISS orbit Earth at 17,000 miles per hour. And their clocks tick just a tiny bit more slowly than ours. It's only milliseconds, but technically, they've aged less. You can see this effect in your everyday GPS as well. Satellites up there feel less gravity, so their clocks tick a bit faster. Imagine playing a racing game where your car and your controller are a bit out of sync. That's why GPS needs constant tweaks, or else your phone would think you are miles away. Gravity also messes with time. Scientists proved it using 2 atomic clocks. Atomic clocks are like the ultimate devices that measure time. They don't tick with gears or crystals, they tick with atoms, the universe's own metronomes. One clock was on a skyscraper roof, the other closer to the ground. The lower one, feeling stronger gravity, ticked just a tad more slowly. The difference was tiny, but it proved that even height can tweak time. Now picture being near a black hole where minutes could equal years elsewhere. This might help you get those mind-bending scenes from Interstellar. So yes, time bends, and scientists know this. And the challenge now is learning how to do it on purpose. Einstein's work proved that time could move differently for different observers. The faster you move, the more slowly time passes for you. This phenomenon is called time dilation. Think of Marvel's comic Flash. He runs incredibly fast, but he doesn't really slow the world down. His own clock runs more slowly, so to him, everything else looks frozen. If you could reach the speed of light, your time would almost stop entirely, while the rest of the universe would keep racing ahead. For decades, physicists believed that was the only path to real time travel. But the Flash is a superhero, and Einstein proved that nothing with mass could reach that speed. The faster you go, the heavier you become, and the more energy it takes to keep accelerating. To actually reach light speed, you'd need infinite energy, because your mass would become infinite too. Since infinite energy doesn't exist in the universe, it's physically impossible. That's why physicists started asking questions like, if time can stretch and bend, could it also fold? In 1994, physicist Miguel Alcubierre posed a question. Could Einstein's math let us travel faster than light, not by breaking the rules, but by bending space itself? His answer was, maybe. He imagined a warp bubble, a region of space surrounding the ship that moves with it, carrying it along like a cosmic conveyor belt. In this bubble, the spaceship itself doesn't move. The space in front shrinks, the space behind stretches, and the ship rides the wave forward like a surfer gliding on a moving sea. Inside the bubble, the ship feels no motion. It's sitting still, but the bubble carries it across huge distances. And because the ship isn't moving through space faster than light, it doesn't break Einstein's rules. The universe itself does the moving. That hypothetical bubble would need a special kind of energy to bend space-time this way. Originally, Alcubierre's equations required negative energy or exotic matter, a substance that's never been found in usable amounts. Early estimates said we'd need more energy than Jupiter could provide. For years, scientists have wondered if the universe could allow something like a cosmic shortcut without breaking the known rules of physics. While nothing practical has been found yet, theorists have explored models that closed time-like curves, loops in spacetime that bend back on themselves. Here's how it works. Imagine space-time as a giant sheet. Normally, moving across it takes time, like walking across a field. But a closed time-like curve is like drawing a circle on that sheet. If you walk along it, you could eventually end up back where you started. In space-time terms, the start and end could be different moments in time. So instead of just moving through space, you're following a path that loops through time, a theoretical shortcut to the past. This isn't pressing a button to hang out with your younger self, it's more like a time detour, a loop in the universe that could let something trace its way back to the past, all without breaking the speed of light. Einstein's math already lets space-time do gymnastics near spinning black holes, twisting like a cosmic corkscrew. Physicists can explore these loops on paper, but creating one in a lab is far beyond our reach. If one day we could turn this math into a real spaceship, a warp bubble wouldn't actually make the ship go faster than light. Well, technically, there would be no speed. Inside the bubble, the ship wouldn't move at all. Instead, it would fold space like a piece of paper, bringing two faraway points together. The ship could get there in minutes while still obeying the cosmic rules. This is how it worked in the famous Star Trek series, and what many movies adopted as a method for space travel. In a hypothetical situation, a warp bubble wouldn't just be for spaceships. You could send a probe, a package, or even a cup of coffee across the galaxy without it actually moving through space. It's pretty cool, because since the bubbles move space around it, everything inside stays totally still relative to the bubble, which means no spills and no weird forces acting on the coffee. However, we are still far away from that point. The challenges we face are pretty massive. We still don't have enough energy, and folding space-time at will is still out of our reach. But for the first time, the math suggests that it's not impossible. What used to seem like pure sci-fi is now popping up in real science journals. These concepts aren't just about whipping up time machines or warp drives. Even if we never pull off a warp drive, figuring out how space-time works is a big deal for understanding reality. For now, it's all theory and simulations, but every experiment pushes the impossible line a little further. Yesterday it was no, today it's maybe. And in science, maybe is where the most exciting things happen. So while we're not ready to build time machines or bubbles across galaxies yet, scientists can now study and test these ideas using real physics, which will lead to new exciting discoveries. That is, unless future Earthlings figure out how to do it maybe 1,000 years from now, so they travel back in time to show us how we can do it ourselves, which will create a grandfather paradox. Unless